software development methodologies, right? So what are the different methods we choose while developing the software? Okay, now this is not your software testing, right? Software testing a part of it. Okay, software development methodologies, how our software is developed. Okay, before we begin, we'll do a quick activity. And you have two case studies here, right? Imagine just starting the lecture and a case study is given to you. How cool is that? Okay, so case study one, right? Don't worry, it's a small case study, right? It's not an in-depth. I'm just kidding. It's not an in-depth. You don't have to do much. It's just normal discussion. Okay, so case study one, right? There's a scenario given. Okay, what is the scenario? A scenario is that a large financial institution embarked on a project to develop a new online banking platform. Okay, so the financial institution is planning to develop a new online banking platform. Okay, that's the project. Right now, the project followed a strict sequence of phases. The first sequence is the requirements gathering. So you gather the requirements, what are needed for the banking platform, what security features are needed, what are the payment transactions, the system design, right? Then they move into the designing of the system. How will they design it? Okay, then they move to the implementation, how they can implement. Implementation is like writing the actual code and writing the actual software, creating it actually. Okay, then they move to the testing phase, then they deploy the product, and then they maintain it. Okay, now the team did not move to the next phase until the current phase was fully completed. So unless your first phase, for example, let's say requirements gathering was completed, they will not move to the system design. They'll not start the system design. They'll gather the requirements first. Okay, then they'll move to the system design. Once that is done, only then they will start with the implementation. If the system design is not complete, if the entire design is not there, they'll not start with the implementation. And until and unless the implementation is not done, you'll not start with the testing. Okay, and until the full testing is not done, you'll not start with the development, and followed by maintenance. Okay, so the next phase is not started until the current phase was fully completed. This approach, right? This approach led to a detailed and well-documented product, but any changes requested after the requirements phase were difficult to accommodate, right? Obviously, because you're going phase by phase, and so you are well documented, right? You have documented it well, and each phase you're documenting. So you've created a thorough product, right? So this looks like a very, very good approach to build the software. Okay. Now the question here, right? My question here to you is, how did the chosen methodology impact the project's ability to handle changes and user feedback? So for example, after they have launched the website, right? After they've launched their banking application, and now they find some issues, right? Now they want to make some changes that maybe this feature is not suited, right? They want to roll it back, they want to change it, or there's some feedback from the users that maybe the user interface is not very adaptive, right? The users are not able to adapt to it, right? It's being complex for them to understand where is the transactions, where is the account statements, where are the past statements, right? It's difficult for them to understand, and they want to make some changes. Okay, now how difficult will it be, or will it be easy, or what do you think will be the impact on this project's ability to handle these changes? What do you think? Is the project able to handle that very easily? Is the project very susceptible to those changes? Is the project easily able to do that? Susan says not very flexible. Okay, Susan, right? That is correct, right? Can you elaborate more on it, Susan? Katarzyna says, I would say that products should be tested and corrected at all steps after creation, as some bugs can be found only when product is in real life use. Katarzyna, that is absolutely correct, right? That is absolutely correct. Okay, so would you say the approach here that we've taken is good? Should we go with that approach, or is it not a correct approach? Valentina says probably not speaking with user until end of cycle. Correct, Valentina, right? So you're not speaking with the user till the end of the cycle, right? So you are speaking with the user only after deployment, right? So once you deploy, then the users can see the product, right? And then they can use it, they can see what is happening. And only then they can give the feedback. And then you can maintain, right? Then your maintenance comes into the picture. You are maintaining it. Okay. Now, is this not a good approach, right? See, because I'm doing everything correctly, right? First, I'm gathering the requirements, right? I'm seeing it thoroughly, right? Whatever is required, I'm gathering everything. Okay. Of course, speaking with the team, right? The entire team is there. You're gathering the requirements, then you're designing the system accordingly. right? The team is discussing and they're designing a proper system, and then they implement it. Okay, and implement it with proper coding and proper documentation, everything you do perfectly. Okay, and then you go to the testing phase. Any issues, minor issues, you change it, right? You correct it, and then you deploy it. After which you get the user feedback, and then you maintain it. Okay, what is the problem here, right? Is there any problem, firstly, right? Do you think there is any problem? Theodora says it must be more difficult for changes. I imagine they have to start from the very beginning every time there's a change, right? That's a great point, right, Theodora? That's a great point. Francisco says it can occur on issues not accounted before, and you have to revise everything after the issue surface. You have the risk of real life scenario not think of in development, right? That is well put, right? That is well put, Francisco. Absolutely right. That is spot on. Theodora, Francisco, that is spot on. Okay, something can always slip out of mind, right? Exactly, Francisco. That is bullseye, right? That is bullseye. Okay, like a simple statement, something can slip out, right? So even though you're a developer and you the entire team is, let's say, excellent team, right? It's the most brilliant team, still there are chances they can miss out on stuff, right? Things can be missed out. No one's perfect, right? Always remember that no one's perfect. You cannot build a perfect software, right? That there just doesn't exist anything like that. Okay, so Ebenezer says very traditional and meticulous approach. Absolutely right, Ebenezer. That is also correct, right? That's a traditional and meticulous approach. That is also true, and we'll discuss about it, right? We'll discuss about it. It's a meticulous approach and it's a traditional approach. That is also true, right? So you have these 2 points, right? You have these 2 points. On the one side, you have the drawbacks. The drawbacks are that if you get any changes, right? If you want to make any changes, it's too late. After the user sees it, after the deployment phase, the user sees it, user's giving you feedback, or you figure out that, oh, I missed out on this thing, right? I want to make some changes now. It's too late, right? It's too late, because now if you go back, because see, after you've designed the system, after you've implemented, you have gone into thorough implementation, and now any changes can break the other parts of the system, right? So if the system design does not incorporate for the change, and you've not kept it open for the change, right? It's like you've built a building, right? Let's say you've built a building, and so let's say in each floor you have 2 flats, right? And you have 5 floors. Okay, now after that you think that, okay, I want to add flat number 3 on floor number 2, right? If you think that I want to add flat number 3, the third flat, on floor number 2, right? It'll be a nightmare. It'll be a nightmare, right? You have the risk of falling the entire building. That's the same thing here, right? That's the same thing here. If your system design does not incorporate that, then you are likely to create a lot of more issues. Okay, and that's why it's not susceptible to changes, right? You cannot make more changes over here. Okay, so this case study, right, this scenario, the drawback is you cannot make changes, right? It's not flexible. Okay, like someone said, right, who said flexible was one of the first points, right? Suzanne, right? Suzanne, it's not very flexible. That is the exact correct thing, right? So it's not very flexible. Okay, on the other hand, it is traditional, right? It is traditional, and it is used because it's a meticulous approach. It is a meticulous approach. Okay, we will discuss, right, when it's used and when this is not used. Okay, Suzanne says, since this project has very well-defined outline, data protection, security, with which it can be developed, flexibility is not as important as accuracy and adherence to rule. Absolutely right, Suzanne. That is also spot on, right? So these are the scenarios, right, when you are not focused on the flexibility. Okay, when you do not care much about flexibility, right? Your focus is on the data protection, the securities, right? Everything is well defined. Okay, so when your focus is over there, then you go for this approach, right? Then this approach is correct. Okay, when your focus is not flexibility, but when your focus is flexibility, then you do not go for this approach. Make sense? Right, let me see what Katarina says. Also, I can imagine that some functions are difficult to test before deployment, as for example, how something works when many people use it at the same time. Absolutely right, Katarina. That's again a wonderful point, right? A brilliant point. And that is where we come with our performance testing, right? So you'll see we have a segment called performance testing, and that is done after deployment, right? So you'll do the performance testing to see how the product is performing when multiple users are coming in, when a lot of stress is given to the platform. Okay, and there are tools for that, right? There are tools for that. We have it in this program. Towards the second half, we'll discuss on that. Okay, second half of the program, right? So after a few months, okay. Valentina says, but who decided not to be flexible if needed, right? Absolutely, Valentina. That is the question, right? That is the question, okay. Who is going to decide whether it's flexible or not, right? Is flexibility needed or not needed, right? How do you decide that, okay? So Binu says maintenance will be more difficult or time consuming based on this approach. Absolutely right. Absolutely. That is correct. Theodore says, I think it depends on the needs, wants of the customer and deadlines. Maybe the customer would rather take the risk of it taking longer for any changes, but at least there is quality, right? Absolutely right. Theodore, that is correct. Okay. That is absolutely correct. Okay. And Valentina, you raised a perfect question, right? Valentina has raised a great question. Who decides on the flexibility? Do we need flexibility here or do we not need flexibility here, right? How do we know that? How does the team even decide on that? Okay. So the key point, right? The key point to note here is that has this software, right? Has the software been built previously, right? Like, has it been built a lot of number of times? How many experience do we have? So for example, if I am the software company, right? And I have built like hundreds of banking platforms, online banking platforms. I've built it 100 times for different clients. Now a new client is coming to, right? Now a new client is coming to me. So I already have that experience of building it 100 times. And since I have built it 100 times, I know what is required where something is going to fail, right? Now building it new, right? I don't need that flexibility. I don't need that, right? So I can gather the requirements. I can talk to the client, right? I can tell them that, look, in an online banking platform, these are the things that we need, right? What are your requirements? We can gather all that, right? And we can tell them that these are the places where you're likely to get bugs, right? These are the places where security lapses happen based on our previous experiences. So we've done it 100 times, so we know it, right? So something that has been done a lot of times, something that has been done regularly, or you have a lot of experience of it, then you're not worried about flexibility, okay? Then you can take this approach. And what is the name of this approach? We'll discuss, right? We'll discuss the name of this approach. But in that case, right, when you have done it so many times, then you're not worried, right? Then you can take this approach. You can go sequentially because you already know what happens after deployment. You have deployed it so many times. You have sent in, for example, imagine like a car manufacturing company, right? So the car manufacturing company has been manufacturing the cars so many times. So they already know what issues if they are building a new car. Let's say there's a change in the design, right? Now they have already built it so many times. They know how to work on it, right? And if there is any issues, then they can obviously rework on it, but they are already so much experienced with it that they can follow this approach. So they can follow this approach. But on the other hand, right, on the other hand, let's take another example. Let's take case study 2. Okay. So let's say you have a startup, right? There's a startup which is aiming to create a new social networking app, right? So you're planning to challenge, let's say, X, or planning to challenge Facebook, right? And you want to build your own social networking app. Okay. The development team is worked out in short iterative cycles. And what are iterative cycles? These are important. Iterative cycles are short iterative cycles, right? So in the first cycle, we do everything, right? So we do this. Because I have a time gap of, let's say, a time limit of 1 week, right? We do all this. We gather the requirements, we do the system design, we implement it, we test, right? We deploy it, we maintain it. Okay. And then again, the same iteration starts, right? Again, you gather based on the feedback. Again, you gather the requirements. Again, you design the system, you implement it. So in short, right? So you're doing short iterative cycles. Okay. So short cycles, you keep doing it. Okay. Frequently releasing new versions of the app. Each cycle included planning, development, testing, and review. So first you plan, right, what is required in the social networking site or app, and then you develop it. Then you test it, right? What are the issues? And then you review it. And then you start the cycle again, right? Again, you plan based on what feedback you got in the review stage. You plan again. Okay, then again you develop, and again you test, again you review. Okay, so team regularly gathered feedback from early users. So now you're gathering feedback from the users on the very early stage, and you're incorporating it into the next iteration. So this allowed them to quickly adapt to user needs and improve the app continuously. Now tell me, is this flexible? Is this approach flexible, or is this approach not flexible? Suzanne said it's a banking app, nothing really innovative needed. Exactly, right, Suzanne? Exactly, right? Nothing innovative needed. Valentina says, I would disagree, using different banking apps, right? Valentina, yes, right? So the thing is that minor changes are there, right? Minor differences are there, but overall architecture, if you see, right, if you see the overall architecture, it's the same. Okay, and same security aspects of it. Ina says, flexible gives room for frequent changes as need arise. Okay, that is correct, Ines. Francisco says the second case is surely more flexible and quality oriented, but really time and probably money consuming, risking useless testing cycle for very minor things and have huge delay on final release. Still true that probably every iteration is shorter than previous one. If stakeholders are not in a rush or on a very strict budget, I suppose it's preferable, but it really depends on the specific needs as we discussed just now. Exactly, Francisco, right? Yeah, that is correct, right? That is correct. But except for the one part, right? So one part, you said probably more money consuming or time consuming, right? No, this is not more time consuming, not more money consuming, right? The iterative process is actually more flexible, right? It's more flexible, and you'll see that the money consuming part is less here, right? It's less money intensive, because see here, if you have any issues, right, if you start this thing again, right, you go to the very start, then a lot of things change, right? You get one issue, and it's very much intensive. Okay, so for example, if you're in your social networking app, you were going from this, right, you were taking this approach, and that'll falter you, right? That'll falter you because that'll cost you a lot of more money. Okay, we'll discuss that, right? We'll discuss these approaches, but that is correct. Okay, Theodore says it's a lot more flexible than the previous, right? Exactly, right? BB says flexible, right? Exactly, exactly. Valentina says, so this case two is app developed and frequently checked and retested, redeployed. Exactly, Valentina, that is correct, right? That is correct. So you keep doing that, right? That's the iteration. That's the iteration. We'll deep dive into the details of this iteration as the method is there, right? We'll deep dive. And this is known as agile methodology, right? So this one is known as your agile methodology because it has agility, right? It's flexible. Agility means it's flexible. Okay, it can do this, do that, right? So it's flexible. Okay, this is agile methodology, and this one is known as a waterfall method, right? It's like a waterfall. What is a waterfall? If you've seen a waterfall, right, what you cannot have the water that has gone down, you cannot go back up again, right? So the water has once fallen down, it cannot go back up, right? So it just goes in one direction. It's unidirectional. That's a waterfall. Okay, so this format is known as a waterfall technique, and it's just flowing in one direction, right? You do the first stage, then go to the next stage, then the next stage. You're just going in one direction. Okay, that is unidirectional. Okay, so the second one is the agile, right? It's the agile methodology. So we'll discuss on that, right? So we'll discuss these two methodologies. That is our agenda for today's lesson. Okay, these two methodologies, and there are some hybrids also, right? So we'll discuss some hybrids also. Okay, Stephens' second approach is flexible, right? Regular user feedback, absolutely correct. Okay, Rasmik says flexible, right? Correct. Samson says flexible. Karin says, I have a question. Is that always step-by-step process, like step 1, step 2, step 3, etc., or is it possible to move from test to gather requirements, etc., when needed? No, Katarzyna, it's step by step, right? It's step by step. Okay, so there is step-by-step sequence, right? You have to follow that. The team follows that. Okay, like there has to be some approach, right? There has to be some systematic approach. It cannot be anyone is doing anything, right? Like you cannot, like, today you decide to do step 3, right? Let's say today you decide to do testing. Tomorrow you're deciding to do, let's say, I want to plan again, right? My planning was not well. While looking at the testing, I thought that, okay, some plans should be changed. So tomorrow you start doing the planning. It does not work, right? It does not work. That planning will come in the next iteration. So first you plan, then you develop, then you test, and then you have to review, right? After that, you have to review. You have to go in the sequence. Okay, based on that review, then you decide on your next plan in the next iteration. Okay, then you decide on the next plan in the next iteration, right? So that is agile, right? So same iteration has to go on again and again. That is agile methodology. All right. Okay, so there we are, right? Seraphim has given it us. Case study 1 is waterfall methodology, and case study 2 is agile methodology, commonly followed, right? Yeah, agile methodology is very common and very much popular, right? Because you can imagine, right? You can imagine in today's world, you need to develop some app, or you need to develop some online platform. Let's say you're trying to make some e-commerce website, some different, right? You when you start off, you don't know what features you're going to add, right? What new features can come in. You don't know that. Okay, and startups generally, they want to make the changes, right? They want to be flexible. Okay, so that is the thing, right? That is the thing. Suzanne says, without knowing requirements, how do you know what to develop and test? Correct, Susan, right? Correct. So that is why the first thing is you have the requirements, right? So first thing is you have the requirements. Okay. So here also you see in the planning, right? In the planning stage, you have all the requirements. Here also you see you gather the requirements first. And also, if you remember from our last lecture, right, in our introduction to software testing, I told you how important is it to communicate with the stakeholders, right? So the client is there. It's important to communicate, and the requirements gathering. This part is very, very important, right? So that you know what is actually needed in the software, right? What are the functionalities needed? So that should be very clear. Okay, that is where communication is very important, and that part is very, very underrated, but it is important, right? Extremely important. Okay, so then at that stage, right, requirements is very important. Okay, so before developing and before testing. All right. Okay. So these were the two case studies, right? These were the two case studies and the questions that we discussed, right? Let's move on, right? Let's move on to the introduction now. Okay. Now, let's say, just following up on it, right? Let's just follow up on the discussion that we did. So imagine you're planning a road trip, right, with friends. Now you have two options for reaching your destination. You can take the direct route along the highway or embark on a scenic route that winds through small towns and countrysides. Okay, so you have two options. One, you can take a direct route. So there's a highway, you go speed fast, right? Direct route. And the second route is that you wind, right? You wind through the towns and countrysides. Both routes have their advantages and challenges. The direct route offers speed and efficiency, but may lack excitement, while the scenic route promises adventure and discovery, but may take longer to reach your destination. Okay, so these are two approaches, right? So if you compare this with the first one is the taking the highway route is your waterfall method, right? The first scenario. And taking the scenic route, right? Taking the scenic route with small towns and countrysides is your agile methodology. Okay. Which one would you prefer, right? By the way, just side note, which one would you prefer? The direct highway or scenic route with the countryside and towns, right? What would you prefer? Okay, so the same thing, right? Same thing in software development. There are different methodologies that the teams can choose from. And like we saw, right? Like we saw, those are the two popular methodologies that we have. And they have the benefits, right? There are trade-offs. So there are trade-offs. The first one has some benefits. The second one has some benefits. So you have some trade-offs. Okay, so some methodologies prioritize efficiency and predictability while others focus on adaptability and collaboration. So in your agile methodology, you have adaptability and collaboration. Well, in the first one, it's more efficient and predictability, right? So you can predict what's going to happen, and it's more efficient, right? Of course, because you're spending so much time on it, right? If you spend so much time on the design phase, you're likely to figure out most of the problems, right? Because you have you have done it so many times, and B, you are capable of finding the issues, right? So you must have already found so many issues. If you spend time on it, right? You spend time on it, the entire team is spending a lot of time as compared to an agile methodology. You want it fast. Okay, in the agile method, you want it fast. So adaptability is more over there, but efficiency and predictability is more in the waterfall. Okay. So just like in the planning the road trip, right? Just like the right methodology depends on factors like project requirements, the team dynamics, and organizational goals. So which route will you choose for your development journey, right? So let's explore the options and find the best path forward. Okay, so that's the lesson that we are going to have today, right? We are going to differentiate between the waterfall and the agile software development methodology. So these are the two broad methodologies you have. One is the waterfall and one is the agile. Okay, and we'll differentiate between the two, right? When you need the first one, when you need the second one, and what are the advantages, what are the disadvantages. So we'll describe the principles, strengths, and weaknesses of the agile methodologies, and including Scrum, XP, and Kanban. We'll look into these. These are different parts of agile methodologies. We'll discuss some concept of hybrid methodologies and their applications in real world scenarios. So these are the objectives of our lesson today. And yeah, before that, right, before I move forward, tell me which one would you prefer, right? What's your preference? The direct highway or the scenic route? Which means you can use your own style. Both are correct. Absolutely right. Maybe there's nothing wrong with the waterfall, right? So yeah, see, just because agile is more adaptive and more flexible, does not mean waterfall is bad, right? No, no, waterfalls is also used, right? That is also used. It has its own advantages. Okay. Uh, Resmic says, without kids, long one. With kids, time is priceless, right? Short one. Absolutely right. That's a great one, right? That's a great one. Okay. Susan says it depends on many factors, right? Exactly, right? Like Presmic says, and Susan says it depends on many factors. Exactly, right? Exactly. It depends on so many factors. And that is what determines, right? That is what determines which approach you should take, right? Should we go for the waterfall or should we go for the agile, right? Should we go for agile? Okay, so depends, right? Depends on a lot of factors. Okay, that has to be discussed. The team discusses all that in the planning stage, right? In the initial stages, they discuss that. What do we go, right? Which approach do we take? Okay, and based on that, they decide. All right. So let's move forward, right? Let's move forward. So what is the software development process? As we discussed, right? Last time, you remember we discussed the SDLC. Who can quickly tell me SDLC, right? What is the full form of SDLC? Quickly tell me the full form of SDLC and STLC. We did two, right? Last time we did two. One was SDLC, one was STLC. Okay. What are the full form of those two? Not going into the details of the differences, right, that we discussed last time, but quickly tell me, right? I'll see how much you remember. Susan says software development lifecycle. That is correct, right? Valentina, correct. Samson, correct, right? Absolutely correct. Software development lifecycle. Francisco, correct, right? Swarupa, that is correct. Inas, correct. Absolutely right. Binu, correct. Stephen, that is correct. And software testing lifecycle, right? Stephen, that is 100%, right? Well done, right? Stephen, well done. STLC. Inas, correct, right? Software testing lifecycle is STLC, right? Perfect, right? Perfect. You all remember, right? Excellent, right? Wonderful. This batch is amazing. So you all remember it. Great, awesome, right? Awesome. And revise, right? Revise. What is the difference between SDLC, STLC, right? Revise that. Okay. Not right now. I cannot go into the details right now, but just revise that later on for your, because that's very important from ISTQB perspective also. Okay. So software development process, right? A development process is a model that guides us on how to build the software by. Okay. So like we were discussing earlier, right? You cannot jump on any step. There should be a guide, right? There should be a guide which will tell you that let's go with this approach, right? Let's go like this. Okay. So the entire process, because otherwise it'll be chaotic. If you don't have something to guide by, for example, in this lesson, right? In this lesson, we have this guide, right? We're going step by step. Okay. If we didn't have, right? If I had jumped to, let's say, this part, right? Scrum first, and then I come back to the conventional life cycle, right? If I keep jumping, then that'll be chaotic, right? It'll be chaotic and not easy to understand. So that's the thing, right? You have to have a process, okay, that guides you. And that guide is the frameworks, right? That guide is the frameworks. Okay, so that will define the stages. It will establish the relationship between the stages, right? So what are the different stages you have? And it defines the relation between the stages, specifying the activities required at each stage. So at each stage, let's say the planning stage or the requirement stage, what are the activities you need to do? In the implementation stage, what are the activities you need to do? In the deployment stage or testing stage, what are the activities you need to do? And what are the relation between these different stages? Okay, so that is a guiding process, right? So that is the guiding process. Now, note, you can't manage something if you don't know how it works, right? Exactly, right? So you cannot manage something if you don't know how it works. So definitely you need to have a guide, right? That guide is what are these frameworks. Okay, so in early days, what used to happen, right? In earlier days, what you used to do is you do the code, right? You do the code, you test, right? You test and see what is the output, okay? How it works in the output. And you see some problems, you go back again, you change your code, and again you test it. You test it, you check the output, right? How is the output working? Is the output good, output bad? Some issues, right? You face some problems, again you go back to the code, right? You test it, you do this was how it was done in the earlier days. Okay, but there were challenges, right? There were challenges to this. Okay, and you needed a streamlined approach, right? You needed a streamlined approach for doing a rapid development, right? To do a rapid software development, you need a streamlined approach and you need some frameworks. Okay, you need some guides. Okay, the guides that we talked about. Okay, so rapid software development and delivery is now the most important requirement for software systems. So in today's system, right, most of them that you see, they require a rapid and fast delivery, right? They want agile, right? They want agile. So that's why it's very popular. But that does not mean that waterfall is not needed at all or it's bad, right? Nothing like that. Okay, there are places where that is required. All right. So in today's world, right, you need rapid and fast delivery software. Businesses operate in a fast changing requirement, and it's practically impossible to produce a set of stable software requirements. Software has to evolve quickly to reflect the changing business needs. So you need something that is adaptable, right? Something that is fast. It's agile. Okay. So the things that you ask, right? So the things that you ask in the software management. Okay, so if you want to manage the entire software, so the client has come to you, right? You want to manage the software. How do you do that, right? So it's like maintaining a home, right? It's like maintaining a home. There are always repairs and improvements to be made. Okay, but when you consider for repairs, right, you ask yourself three things. You'll ask yourself three things. First thing is, how soon do I need this to be done? So let's say something is not working, or you have a leakage in the ceiling. Okay, you ask the question, how soon do I need to get it done, right? How much do I have in the bank to pay for it, right? Do I have the sufficient balance in the bank to pay for the changes that are needed? And what task will get done the way I want, right? What task will get it done the way that I want it? So these are the three important questions that you need to ask for managing that. Okay, so this is the diagram, right? This is the diagram that how much time will it take? What is the scope of the task that we need to do? And what is the cost that will take, right? So you have a task, just like in managing your home, you need to change something, right? How much time will it take? How much will it cost me? And what is the scope, right? Do you want to change, let's say, do you want to scrape the entire wall off? You want to change it, or you just want to apply some quick fix, right? So what is the scope, right? What is the scope of it? Okay, so these are the things, right? These are the things that you need to consider, and that is your dilemma. Okay, so based on that, you decide, right? The same thing happens in businesses, and these three things are known in the project world as the triple constraint, right? So this is an important thing. It's a triple constraint. Uh, so it's known as the time, resources, and the cost, right? So this is the triple constraint: the time, the resources, and the cost, right? So the schedule, scope, and the budget. Okay, you may have heard of it as iron triangle or project management triangle, but it's the same thing, right? So yeah, this is the triangle, iron management triangle, or the project management triangle. You must have heard of it, right? Maybe in your workplace. So this is what they're talking about, right? So whenever you have something, you have three things, right? How much time is it going to take, what is the scope of it, right? And how much cost will it take? Okay, so that is your triple constraint. All right, has anyone heard of it? Has anyone heard of the triple constraints? So then gives a thumbs up, right? Great, awesome, awesome, right? Awesome. Okay, and Seraphim has given us few examples, right? Great, great. That's wonderful examples that Seraphim has given us. Go through those, right? Some great examples. Stephen has heard of it, right? Valentina has not. Jixing has heard, right? Awesome, right? Awesome. Great, great, right? Amir says yes, right? Perfect, right? Perfect. Okay. So that is the thing, right? That is the thing about the triple constraint. You need to figure out based on your project, right? Now, the conventional life cycle, right? So the conventional life cycle, so in the waterfall development, right? So we are into the waterfall development. It's another name for the traditional approach. So you see, this is the most traditional approach to software development, and this is how it used to be done earlier on, right? So earlier, this was the approach. Okay, so the waterfall development, also known as the plan-driven approach, is linear approach where all phases of process occur in a sequence. So you have to follow the sequence, and this diagram shows it to you beautifully. First, you do the requirements, right? So this is the first stage you have to do, right? Gather all the requirements, and then you move down. You see, you're moving down to design. You cannot jump back here, right? So look at this as a waterfall, right? How a waterfall flows. So you go from requirements to the design phase. You design your system here, right? Then you go to the development, right? You start with the development, then you go to the testing, and then you go to the maintenance, right? Once you go down, you do not go back up, right? So in this process, you're not going back up, right? You cannot go back up. So therefore, when you are here, right, at the requirement stage, you will take a lot of time. Take a lot of time, make it as exhaustive as possible. Discuss with the teammates, discuss with the clients, right? And gather all the requirements that you need, because you know you're not coming back to this stage. So here you can take a lot of time, right? Take time. Here also take time. Design, right? Because you're not coming back. Because once the development starts and there's some fault in your design, then the development will falter, right? The development will falter, and by the time you're in the testing stage, you discover that fault. You're already gone, right? You're already gone, because now you cannot start again, right? Because if you start again, it's going to take a lot of time. Again, you develop and then testing, right? So that's not possible. All right. So this is the waterfall, right? This is the waterfall stage. Requirements, right? So first stage is requirements. The first stage involves understanding what needs to be designed and what its function, purpose, etc. are. All possible requirements on the system to be developed are captured in this phase and documented in a specific document, right? So you document it in a in a separate document, right? You just document it. Okay, what are your requirements? You design the system, specify the hardware, the system requirements, such as the data layers, the programming languages, the network infrastructure, the user interface. You design everything. Okay, you design your interface, your backend, right? Which programming languages you're going to use, which database system you're going to use. Do you use a relational, non-relational? Don't worry about these keywords, because this is again the part of the developer stage, right? So this is the developer stage. You don't have to worry about it, right? How the database is created, or how the user interface is created, or what network infrastructure is required, right? What programming languages are required, right? Don't worry much about it, because that's not part of the testing. Okay, that's part of the design stage for the developers. All right, then if the implementation, right, development is done. As the name implies, the source code is written here. The physical design specifications are turned into a working code now, and the system is developed in small programs called units. Okay, after which these units are integrated. So you design in small units, you write small units of code, and then you integrate them. Okay, this is important, because you have different types of testing, where you do some unit testing, you have some integration testing. So you do all those types of testing. So how it's developed in the implementation stage, you make some small pieces of program called units, right? So one unit for, let's say for adding the cart, right? So in a shopping website, you have the cart. Okay, the add to cart. And so one unit for that, right? One unit could be for the login or sign up functionality, right? One unit for the products page or the catalogs, right? So different units for that, and these are then integrated later on. Okay, then the testing stage, right? Here the code is handed over to the testing team, right? So once the code is implemented, and now the testing team comes into the picture. And it's not that now they come into the picture. I just want to clarify one thing. It's not that the testing team is not doing anything over here. All right. In these stages, it's not that testing team is doing anything. No, testing team is still part here, right? Testing team is part, right? So as a software tester, you're still part of this, right? You're part of this, and any issues with the requirements, or let's say from the design, right? When the system is being designed, and you know as a tester that this design might cause some bugs, right? You given that input, but the thing is, you don't do the actual testing of, let's say, running the program, or let's say doing automation testing, right? Or doing, let's say, manual testing. You're not doing that till this stage. Okay, so till the time the code is ready and everything is ready, you don't do that testing part till that point, right? So that is the thing. Okay, but it's not that you're sitting idle in these stages, that the testers are not doing anything in these stages. It's not like that. They're still part of the team, right? And they given that input, right? Everything is being discussed, so that they know what is the exact system design, and they can create their own test cases, right? So once you know what the design is, so you can start creating, because you know what the design is. When the software developer team is implementing it, right? When they're writing the code, you can start writing your test cases, right? You can integrate, you can write your test cases, right? So you design your test. Okay, here testing is where you actually do the test. Here is where you're implementing the test. You're performing the test and seeing how it is performing. Okay, like manual test cases, or you can do automation testing. Okay, so the client is also involved in the testing phase in order to ensure that all requirements are met, right? Maintenance, the last one after the deployment phase. The next step is to provide support and maintenance for the software, making sure it runs smoothly. If the client and end users come across defects, bugs during use, fixing them is the main purpose of this stage, right? So if you have any bugs, issues noted by the team or by the client, then in the maintenance phase, you fix them. All right. Making sense, right? Making sense. Clear so far? Any issues, any questions? Okay, Valentina says, so Waterfall and Agile are types of SDLC, right? Absolutely, right? Absolutely. I see Seraphim has given a wonderful reaction to that. Great, awesome, right? Awesome, right? Perfect. Okay. B says clear, right? Presmic says clear, right? Great, awesome, perfect, right? Perfect. Okay. Vinu gives a thumbs up, right? Others give a thumbs up, right? Give a thumbs up if everything is clear so far, or not understanding something, any issues. Okay, Ines says, when you say the client is involved during the testing phase, please could you tell how they're involved? Absolutely, right, Ines, absolutely. Okay, so let's say the product is built, and let's say we are building that social networking app, right? From the scenario two. Okay, so we built a social networking app, and Oh, let's say this is the waterfall, right? So waterfall, take the scenario one, right? The banking application. So we've built the banking application. Okay, so all the stages were followed, right? We had the requirements, we designed it, everything was done, implementation is done. Now we're at the testing stage, right? Now, see, the client knows exactly what they want, right? So you as a tester, you might create testing cases, right? But you might not be from the banking domain, right? You have no idea about the banking domain, or you're not from that domain. Okay, so you might create test cases, right? And it works, right? It works correctly, and the product is working correctly. Okay, but that is not what the user wanted, right? That is not what the client wanted. Okay, so it is important to gather the feedback from the client also, that look, is this what you wanted? We're testing it like this, right? Is this what you wanted? The client says that no, I wanted it from this functionality, right? So you can create your test cases accordingly, right? And you can change your test cases to see whether that particular functionality has been made by the developers or not, right? So you can then test that, and you'll see that whether your test is passing or failing. Based on that, you can tell the client that, look, this test is failing, right? So this functionality is not there. How important is it for you? The client will say that, I want that functionality, right? I want that functionality. It was there in my requirements. So then you can tell the team, and then they can amend it, right? So it's makes sense, right? Makes sense, Ines, right? Makes sense. Okay, I see a lot of thumbs up, right? Great. Awesome. Awesome. Stephen says, testers can contact the clients direct, not the business. They are the stakeholders, right? See, yeah, stakeholders are part of the team, right? So that is the collaboration, right? That's a collaboration. And they are part of the team, and they are kept in loop, right? They are kept in loop. That is correct, Stephen. And it's based on the team, right? It's based on the team. Different projects have different approaches, but yeah, they are there in the loop, right? Okay, awesome, right? Awesome. So Jixin says, so user requirements are also part of the triple constraint. User requirements are also part of the triple constraint, right? Yes, Jixin. Yes, right. So yeah, so that constraint is always there, right? That constraint is always there, right? When you want to add on something, right? So you want to make some changes, right? That constraints will always be there. Okay. So in that requirements will also be there, right? So it also applies to that, right? So that is correct. Ines says yes, but now wondering how this works with waterfall methodology, as we can hardly change anything after the start, right? Absolutely, right? So you can't change anything, but maintenance is there, right? Maintenance is there. You can make some minor changes, right? So major changes. So the drawback of this waterfall methodology is that major changes is not possible, right? Major changes is not possible. It's possible, obviously, but again, it'll take a lot of time and effort from the entire team, right? So the entire process has to be followed again, and it's very much time intensive, right? This will take a lot of time. If you start again, it'll take a lot of time. It'll take a lot of time and a lot of resources. The team will be involved, and the time, right? The time of the team is also a resource, right? So if let's say your 5 members of the team or 10 members of the team are let's say for the next 2 months are involved in this project, and then you feel that after 2 months, again 2 months have to be gone to this project again, right? So within that 2 months, the team members could have done something else, right? A new project could have been done, and so that time cost is also there. Okay, so time is valued of the team also, right? So that is there, right? And you have this maintenance, right? Ines, you have this maintenance phase. Here you can fix it, right? Here you can fix it. It's generally because, see, when you're going for a waterfall method, right? When you're going for a waterfall method, what did I tell you? You already know that you're not going to reach the stage again, right? You already know that. So you're spending a lot of time here. You're spending a lot of time in gathering the requirements. So you have talked to the clients thoroughly. You have it documented, right? You have written communication with the clients, okay? And they have approved it. Yeah, these are my requirements. I don't have any other requirements. So you have finalized this, right? After a lot of talk here and to and fro talks, right? So you've done that. You have done it exhaustively. Okay, only then you go to the design stage, and again that is also exhaustive, right? You have already done that, and keep in mind that this approach is only taken when you have done something multiple number of times. So when you've already built the banking application so many times, you have that experience, so you know that, okay, these are the things we have to do, right? These are the things we have to do. If that is missing, you know that has to be added, right? So you'll add it over here itself. You'll tell the client that, hey, you're missing on this. Or if the client is asking for some functionality, you might say that this will cause issues, right? This will cause bugs, right? I know that. Okay, so you're already experienced with that, right? So the team is already that is why you're choosing this waterfall method. Okay, and this is all done very exhaustively, so it's very less likely that you're missing out on some major issues. Okay, and still, right, if you get some major issues, then yeah, it's a huge loss. It happens, right? But it's a huge loss of time, effort, resources, money, right? It's a huge loss for that. But if you have minor issues, right, minor changes and all that, that is done in the maintenance stage, right? So you can, right, so you can fix them, right? So you found any errors, defects, and bugs, right? You can fix them, right? That is the main purpose of this maintenance stage, right? You can maintain it. Okay, makes sense, Ines, right? Ines gives a thumbs up, right? Yeah, awesome, awesome, right? Awesome. Okay. Okay, Theodore has a question, right? So just to be 100% clear, does the client decide the methodology or does the development team decide based on requirements? The team, right? The team, right? It's the clients, they just want a product, right? They'll just say that I want a social networking site like Facebook, right? Or I want it like this. I want a banking platform like this. Okay, so they just tell you that what I want, right? They are not worried about how you implement it. That's not part of their this, right? Okay, waterfall development, right? So that is what we saw, right? You complete one phase, and before moving on to the next phase, you complete the phase, then you go to the next phase. So you rarely aim to revisit a phase once it's completed. This is the key, right? You rarely aim to revisit a phase once it's completed. Done means done, right? The phase is done means that's gone. Okay, that means you better get whatever you're doing right the first time. You better get it right in the first time. Okay, so that's why you spend a lot of time on it, right? And it's exhaustive. You don't realize any value until the end of the project, right? You leave the testing until the end, and you don't seek approval from the stakeholders until late in the day, right? So till this part is done, you don't get approvals from the stakeholders, right? Because the stakeholders cannot see anything. Okay, this approach is highly risky, right? It's risky, often more costly, and generally less efficient than agile approaches, right? So these are the drawbacks. It's highly risky, more costly, and generally less efficient than agile approaches. Okay, what are the characteristics of waterfall, right? What are the advantages? It follows a linear progression, right? Each phase is in a linear format, right? So you know what is the cascading order, and it works best for things that have been done before many times, right? Like I told you, something that you have done repeatedly, like building cars, okay, or building bridges, right? Something that has been done repeatedly, so you have experience. So let's say there's a huge, big software company, and they have built a similar banking application a lot of times, right? They have already built it for different clients, so they already know that, right? Then they can take this approach. Disadvantage is what? It's late design breakage, right? It's a late risk resolution. If you have a risk, resolution is very late. Requirements driven functional decomposition. Adversarial stakeholder relationships, right? So stakeholders has a adversary because stakeholders are come in very late, right? They come in very late. So adversarial stakeholder relationships, because at the end of the day, they might say that I didn't want this, right? I want this. Okay, and then you are stuck. Okay, so focus on documents and review meetings. So it has to be well documented, and the review meetings are also very well documented. So focus has to be on those, right? The review meeting, because if you miss out on any stage, then you are not coming back to that, right? So you have to be very thorough with your meetings and documentations. That there's no chance of making you cannot leave the documents and meetings to any issues, right? You have to have it thoroughly done. Okay, there's limited flexibility, right? Like we discussed, there's very limited flexibility. Okay, so time for some exercise, right? Time for some exercise. Arrange the steps of the waterfall development model in the correct order for creating a mobile banking application, right? So there's a banking application from scenario one still going on. Now you have some steps given to you, right? Some steps are given to you. I'll tell you how to do this, right? I'll tell you how to do this before doing it. So first look at this, right? So you have these chunks of code, right? So the chunks of text, right? So first one is run the mobile banking app on various devices to identify defects, ensuring all security and functional requirements. And you have these five pieces, right? So you have these five pieces of text. What you have to do is at the bottom, you'll see a box, right? There's a yellow box. You need to drag it, right? So imagine you think that, okay, this one will come first, right? This is the first step in the waterfall method. So you come into this yellow space and you drag it over here. Okay. Then you see that, okay, this one, right? This one comes second. So you take it from here, you scroll down and you can arrange it in the second one. Okay. So like this, right? Like this, I will bring this back, right? I'll bring this back. Okay. Now tell me, which one should this be first, right? Which one should be first in our block, right? Run the mobile banking application on various devices to identify defects, ensuring all security and functional requirements. Define the app's architecture, including the user interface, layout, database structure, and security features. Or should we collect, document, and all the necessary features such as account management, fund transfer, security protocols? Should this be done first? Or should we write the code first to create the app, develop the interface, integrate the payment gateway, and set up the security measures later on? After deployment, fix bugs or introduce updates as users report issues or request new features. So which one should you think should come first, right? Which of this should be first? Tell me only the first one, right? The first part, okay? Only the first part, not the others. Okay, collect and document, right? Collect and document. Hamid says 3, Max says 3, right? Absolutely right. Absolutely right. Yeah, first you collect and document, right? That is the first stage, right? You collect and you document, right? That's your first stage. Okay, absolutely correct. Okay. Second stage, right? What's your second stage? What do you think will be the second stage? Susan says define, right? Max is 2. Okay, okay. Others quickly, right? Define the architecture. Theodora says define the architecture, okay, running the application, write the code, deploy. Absolutely, right? You define the architecture, right? You design it, right? So now you are in the design stage. This is the design stage. You design the app's architecture, okay, how the interface will look like, what is the database structure, right? The database structure is in the backend, which methods you'll use in the database. Will you go for SQL, no SQL? A lot of things are there in the backend, okay? What are the security features, all that, right? So that's the design stage. Third stage, right? Quickly tell me the third stage. Susan says write the code, right? Absolutely right. Perfect, right? Perfect. You'll write the code, right? Now is the fun part of writing the code. You write the code, and next stage, run the application, right? Susan says run, right? B says, Dixon says testing. Tara says run, right? Hamid says run. Absolutely right. Now run the application, right? Run the application, and on various. So this is testing, right? You're testing, basically. You're running on various devices, identify defects, ensuring all security functional requirements are met or not, right? So you're testing it essentially. Okay, and then after deployment, see, in case you're not able to drag it, first drag it here, right, and then scroll down, and then take this again, and you can drag it down, right? Like you can interchange it within the yellow box also. Okay, so that is the stage, right? After deployment, you fix the bugs, introduce updates as users report issues or new features, right? So let's check that, right? That is green, right? Green means you are correct. Okay, so that is the exercise you all can do in your audio as well. Okay, now let's look at a real world scenario, right? NASA Apollo program, right? So real world scenario. So NASA Apollo program is a classic example of the waterfall development model in action, right? So you might have felt that what is the when do we even use waterfall development method, right? So it's not popular, but it's still right. It's still important. For example, in the NASA Apollo program, right? So here's a brief overview of how it was applied. First, requirements were gathered. NASA defined clear objectives for the Apollo mission, such as landing the man on the moon and returning him safely to Earth. So what are your requirements, right? You clearly and you define it exhaustively because you're not going back, right? You clearly define it. Then you design the detailed designs for the spacecraft. Mission plans were developed. Implementation, the spacecraft and mission components were built and tested. You implement it. Then you verify, right? Rigorous testing was conducted, including unmanned and manned flights. And then maintenance. After each mission, the spacecraft was examined and improved for further subsequent missions. You improve it. Okay, that's the maintenance stage, right? So this is the waterfall stage, right? This is a waterfall methodology. You do each phase, right? Each phase had to be completed before moving to the next, right? If you don't do the first stage properly, you're not going to the next one. Okay, reflecting the sequential nature of the waterfall method. This approach was suitable for Apollo due to high risk nature of the space exploration and the need for thorough planning and testing. Okay, so when you have a high risk nature and you need thorough planning, testing, right? You need a thorough. Okay, because in Agile, it's not done that thoroughly because you can do it in the next iteration, right? Again, you have another iteration. If it's not done in this iteration, you go to the next one, right? Not done in that one, go into the next one, right? Any issues coming, you go in the next one, right? But here there's no such case, right? So therefore, because once the rocket has gone, right? Once the rocket has gone to space, anything happens, right? It'll be disastrous, right? It's not coming back. Okay, so you have to be thorough, right? You have to be thorough at each stage. So that's the thing. Okay. Makes sense, right? Makes sense. And if you find this interesting, right, there is a link to read through more of this. I'll share this link in the live chat. You can give it a good read if you want later on, right? You can give this a good read. It's interesting, right? It's interesting. So that's your waterfall, right? That's the waterfall method. Okay. Now let's look at the iterative, right? Let's look at the iterative model. Okay. Now what's your iterative model, right? Iterative and spiral models. Let's first discuss the iterative model. The iterative model allows the development effort to be aligned with the business requirements, uncovering any important issues early in the project and therefore avoiding disastrous, faulty assumptions. Okay, so it is more aligned with the business requirements. Okay, how does this happen? So, for example, you have look at this image, right? Look at this image. You have the requirements planning, right? You do the requirements, you plan, okay. You analyze and you design, you implement, right? You implement it, okay. Then you can deploy, you can do the testing, right? You do the testing, right? Not deployment first, you first test, right? So first you do the testing, you evaluate, right? You evaluate how it is done. And so you start from here, right? From the initial planning, you do the requirements, you analyze, right? You do the testing. Again, you evaluate how the product is. It will not be the perfect in the first iteration. You know that you have more iterations, okay? So just a basic one in the first one. Then you evaluate and you see now what are my new requirements. Okay, now I can change my plans accordingly. And then again, you analyze the design, you implement it. Again, you do the testing, and again, you evaluate. Again, you do the same thing, right? So this is the iteration, right? This iteration keeps on happening. And once you are at a stage where you are sufficiently satisfied, the users, the stakeholder, the client is satisfied, then you can deploy it. Okay, so that is the approach, right? So in the iterative model of the software development, the project is broken into small versions and developed incrementally. However, it must be recognized that if the planning cycles are too short, non-functional requirements, especially security requirements, can be missed. And if it is too long, it can lead to delayed delivery, reduced agility, increased risk, and higher cost, and decreased team motivation. Okay, because you see, this is the iteration. You have to define the time period of one iteration, right? Where the one iteration will take 1 week long, 1 month long, 2 months long, right? Or 15 days, 20 days, 1 day, 2 day, right? How much? Okay, so that iteration will take how many days, right? That has to be decided, right? If it is very short, right? If it is too short, then what happens? Some non-functional requirements, like let's say the security requirements, you can miss it out, right? Why? Because see, within 1 week, right? Or let's say if 1 week is the time period for one iteration, and the team is doing it, right? The team is doing it. So they are first focused on the requirements, right? What is the requirements? They design it, right? And they implement it. They're writing the code, and then you test it. So what might happen here is that you might negate the security part of it, because that's generally done in the last, right? So first you build out everything, and then you test for the securities. And if you don't have sufficient time, right? If let's say if it's too short, for example, let's say 2 days, right? Our iteration period time is only 2 days. Then you'll have to leave out something, right? And generally security part is what is to be missed out, right? So you'll miss it out. Okay. And if it is too long, right? If it is too long, it can lead to delayed delivery, right? For example, if this is one iteration is 1 month long, so one iteration is done, then you go to the next iteration in the second month, then again the third iteration, right? So it might lead to delayed delivery, and that is reduced agility, right? And higher costs, decreased team motivation, because the team is doing the same thing, and it is demotivating. Okay. Potential pitfalls, right? Scope creep. As new iterations are added, there's a risk of scope creep, where additional features and changes expand the project scope beyond original intentions. And this is very often, right? Happens very often, right? What is scope creep? So you have defined a scope, right? You have defined a scope for your application. These are the things that will be there in the let's say you're designing that social networking site that we discussed earlier in scenario number 2, right? So you're designing the social networking app, and so we have decided our scope, that users will be allowed to chat with each other, users will be able to send friend requests to each other, right? And they can add posts, they can like the different people's posts, right? And they can see what other people are doing, and they can chat with each other, right? There's a chat segment, and they can chat with them. Okay, so that was the scope, right? That was the original scope. But later on, right, later on in few iterations, right, as new iterations are added, they decided that let's say we want to add calling feature also, that people are able to call, right? That they are able to video call each other also in the chat section. right? So these are you're broadening your scope, and there's no there's no limit to it, right? You can keep broadening the horizon as much as possible, right? So that is the scope creep, right? That is the scope creep, and that can the project it can expand the project scope beyond the original intentions. Okay, and that's not good, right? That's not good. Okay, it can increase the complexity, right? So complexity of the management, managing the integrating multiple iterations can become complex, because see, ultimately someone has to manage it, right? So first iteration, second iteration, what was done, what is left out, right? Then the third iteration, what was done, right? You have to manage that. Okay, and it requires diligent oversight and clear communication to avoid inconsistencies and integration issues, because there might be inconsistencies in iteration 1 and iteration 2, iteration 2 and iteration 3, right? You don't want that, so clear communication has to be there for that. Okay, and that's why I told you initially in the last class also, why clear communication is very, very important, especially for software testing. Okay, suitable projects, right? The iterative model is particularly suitable for projects where requirements are expected to evolve over time, such as software development for innovative products, research and development projects, large scale enterprise applications where user feedback and continuous improvements are critical. Okay, so these are the places where this model is suitable. Okay, let's look at the spiral model, right? What is the spiral model? The spiral methodology is, let me quickly look at the chat, right? Anything in the chat so far? Suzanne says, as always in life, find the right balance, right? Absolutely, right? Wonderful, right? I love that, Suzanne. Absolutely correct, right? Absolutely correct. Find the right balance, okay? You need to find the right balance in life, right? Absolutely correct. Again, Seraphim has given a wonderful waterfall, right? Wow, looks so beautiful, right? That waterfall. So yeah, you can see, right? You can see from that waterfall, right? The water molecules that go down there, they cannot come back up again, right? They're not okay, they can, right, from evaporation and it goes back, but you understand the concept, right? It's going down, so it's unidirectional. Okay, so that's the thing, right? That's the thing. Okay, the spiral model, right? What is a spiral model? The spiral methodology is adept at managing large, intricate, and ever-evolving software projects, requiring continuous adjustments, whereas the iterative methodology is tailored for smaller, straightforward, and steady software projects, categorized by fixed and well-defined requirements. Okay. So what is the spiral, right? The key character of the spiral model is that each phase has risk assessment and review activity. Okay. So if you look at this, right, you look at this diagram. I don't know if you can see this properly or not, right? But how this works, right? How this works is you start like this, right? You determine the objectives, you identify, right? You identify the risk. And so see, if you need to see, you see from the very center, right? You start from the very center. You first identify the see, all this 1 2 is there, right? See, 1 2 3 4, right? So you're going from determining the objectives to identifying and resolving the risk and development and test and planning phase. That's the circle, right? That's the circle you're going from, right? So this quadrant to this quadrant to third quadrant to the fourth quadrant. Okay, but you start from the center, right? You start from the center and you start here, right? You determine the objectives, you identify the and resolve the risk, right? So you start here, right? You build the prototype one. Okay, you build the prototype one. The concept of requirements, right? Requirements plans, right? Risk analysis, like this. So you see how the spiral is working. You do the risk analysis, right? You verify validation, you develop the plan, and then you go right here. Then you have the prototype two, right? And again you develop, right? You develop test, you plan the next iteration. So like this you keep going, right? You keep going and until you have the operational prototype. Once you have the operational prototype, you detail the design, the code, integration, you test and implementation, and then you release. So you see how the spiral is being formed, right? So that is a spiral. Okay, so the key characteristic here is that each phase has a risk assessment and review activity. So if you see here, right, you have a risk assessment and a review activity, right? So you identify and resolve the risks. Okay, and you review it. Okay, you review it. All right, this is the risk analysis, and here is where you are reviewing it. All right, so these are the key characteristics of the spiral model. The risk is, sorry, the risk of not completing the software development project within the constraints of cost and time is estimated, and the results of the risk assessment activity are used to find out if the project needs to be continued or not, right? So that's your risk assessment. Okay, you see whether the given cost and time is sufficiently enough for this or not, right? Or whether the project needs to continue or not. right? So that is your spiral model. Okay. So that is the agile methodology, right? So agile mindset is what are the core values and a real world fit for it. So a brief history of agile. So in agile methods emerged as a response to the rigid and documentation heavy software development approaches of the 1980s and 1990s. So in the initial 1980s and 1990s, you generally had this waterfall method, right? So that was the approach that was taken initially. Okay. In 2001, a group of industry leaders formed the Agile Software Development Alliance and published the Agile Manifesto. Okay, you can click on this and you can go through this manifesto as well, right? I'll share it with you in the live chat. Okay, so that's the manifesto, right? So in 2001, a group of industry leaders formed this Agile Software Development Alliance, right? They formed this alliance and they published this manifesto. So this manifesto emphasized a more flexible and people-centered collaborative approach of creating the softwares, right? This is the timeline, right? You can see the timeline in this image. How the waterfall was there in the 1970s, 1991. Scrum was conceived. We'll talk about Scrum, right? What Scrum is, we'll talk about that. And Agile was there in 2001. All right. What are core values of the Agile manifesto? So the manifesto that I shared with you in the live chat, what are the core values inside it, right? That individuals and interactions over process and tools. Okay, so strong teamwork and communication leads to better results than relying solely on the tools of rigid procedures. Okay, working software over comprehensive documentation, because in your waterfall method you had a comprehensive and exhaustive documentation. Everything had to be documented, everything had to be there. It has to be exhaustive, right? You have to figure out everything. Okay, but here the functional software is focused on, right? You focus more on the functional software is more valuable than overly detailed documentation. So the details of the documentation is not that important as compared to the functional software. Okay, customer collaboration over contract negotiation, right? So developers should work closely with users to deliver what's truly needed. Because in your waterfall, right, if you remember at the last stage, right, if the customer says that this is not what I needed, right? Or I need this, right? I wanted this also additional. This is not how I wanted it to work. That's a fix, right? That's a fix then. Okay, you'll be in trouble. Okay, so here you work closely, right? You closely work closely with the users to deliver what's exactly needed and responding to the change, right? So if the user says that, no, I don't need it like this, right? I want it to be changed like this. So you can respond in an agile manner, right? So you can respond fast and you have a plan to follow up on, right? So the agile teams welcome the change and adapt quickly to the feedbacks. So that is the key here, right? These values are supported by 12 principles, such as delivering working software frequently, fostering sustainable development, and empowering self-organizing teams. You can read all the 12 here in the Agile Alliance. You can read this 12 principles if you want, right? I'll share this one also in the live chat, right? You can read through this. Okay, the 12 principles. Okay, why where agile works best, right? Sorry, where agile works best. So in which scenario would you feel that, okay, here we should use agile? It's mostly popular these days, but you should know the scenarios also. Okay, so agile is particularly effective in product development where frequent updates and feedback are needed, right? When the product will need frequent updates, right? The product has to be changed based on the feedbacks from the user or the stakeholders, right? Clients, you take the feedbacks and you change it, right? The product is changed. Okay. Which is very common, right? Because if you see nowadays in anything that is being, any of the softwares that is being developed, right, there's something new, something changing. Okay, and people always need, right, frequent updates. They want the feedback to be incorporated, right? They don't want to sit as a black box, like wait for 2-3 months when the software is being developed and then they see. No, right? They want to be engaged, because the customer software projects with engaged stakeholders and few regulatory barriers, right? They want to be engaged, they want to see what is happening, right? And organizations looking for a faster time to market, you want to launch it fast, because see, you don't know whether the product will work correctly or not. So let's say we are building our social networking website, right? You don't know whether it will be able to compete with X or with Facebook, right? You don't know that. So you want to first launch it, right? You want to faster time to market and see the users' feedback. How are the users liking it? Are they liking it, right? And then you can accordingly change. Okay, if the customer satisfaction is high and they're motivated, right? Then you can change it, right? Then you can add on more features, right? And you can keep additional iterations. You can keep having more iterations and keep changing the product to make it more effective, more enhanced, and you can keep doing that in the iterations. That is the agile approach. Okay. However, agile can be difficult to scale to very large systems or distributed teams, right? And may not be ideal for highly regulated projects requiring detailed documentation, right? So if you have a project that requires detailed documentation, um, it's not a good choice to use agile framework there, right? Because it's a um, you'll not have the time to do that detailed documentation, right? The time sprints is very fast, right? So one iteration, the second iteration, you simply don't have the time to do that detailed documentation. Okay, so remember, agile is not a fixed process, it's flexible mindset and philosophy, right? So it's not a fixed process that you have to do this, do this, do this. No, it's a flexible mindset and the philosophy, right? So entire mindset changes. Okay, common challenges in the agile projects, right? Keeping customer stakeholders consistently engaged. Now that's a good point of agile, that your customers and the stakeholders are engaged, but keeping them consistently engaged at every stage is a challenge, right? It's a challenge. You have to keep them engaged in every process of it, right? That's a challenge also. Okay, team members adjusting to fast-paced collaborative workflows, right? That's also a challenge. Balancing the simplicity with evolving complexity, handling frequent change with many stakeholders that are involved, right? You have to it's a challenge, right? It's a challenge. You have to manage the frequent changes. Okay, so choosing between plan driven and agile approaches. Okay, so plan based development, you gather requirements, you have a requirement specification, you design, you implement, and you again go back to the requirement stage, right? You again requirement specification, you design, implement. And in agile development, what you do is you do the requirements engineering first, right? So you requirements engineering, then you design, implement, and again you go back to requirements engineering. Okay, so that's the agile development methodology. All right. Most real-world projects blend elements of both agile and traditional models. Here are the key considerations, right? So, like Suzanne said about the balance. Is that correct, right? Yeah, Suzanne said about the balance, right? So, yeah. So, most real-world projects blend elements of both, right? So, in real projects, you blend both of them, the agile and the traditional models. You keep a balance, right? And here are the key points to consider, right? Few key points to consider. Complexity and scale, right? Large or safety critical systems may need more upfront planning. Team distribution may require more documentation. Regulatory requirements, some projects demand extensive reporting. Skill levels, agile can demand stronger collaboration and technical maturity. Tooling support, agile requires tools for tracking progress and changes in design. Right. So designing between agile and plan-driven or hybrid approach depends on the goals, the risks, and context of the project. Right. So it's never a one-way approach. It's generally mostly you go agile-based, but there's a balance, right? You keep a balance. And okay, so that's the hybrid approach, right? That's the hybrid approach. We'll talk about that towards the end of our lesson, but that's the hybrid approach. All right. So interested in exploring more about agile, right? So there is a video, right? There's a video link also that you can watch through. Okay, so the link is there, right? I'll share it in the live chat also, so you can go through this and understand more about agile. All right. Okay. So how testing adapts to agile and modern development frameworks, right? So as software development methods have evolved, so to the role of testing. Okay. So different development models such as waterfall, iterative, agile structure the development process differently, which differently affects how, when, and what testing activities are performed. Okay, so testing in sequential versus iterative agile models, right? So now we are focusing on how the testing part adapts to the different methods. Okay, so when you're in the sequential approach and the waterfall approach, how your testing approaches will differ, how if you're in the agile method, right, or you're doing the iterative approach, how your testing methodology will differ. Okay, so in sequential models, right, like waterfall, the phases of development happen one after the other, right? So like we discussed, one phase, then the next phase, then the next phase. So here testing typically occurs after the software is fully developed, right? So which means many defects are discovered late. So once the software is fully developed, implementation stage has been done, then you do the testing. Okay, so the defects are discovered very late. So making them more costly and time consuming to fix because you're discovering so late and then you have to fix it, right? So however, test planning and design still start early, often during the requirements or the design phase. So like I told you that in the initial stages, right? In the initial stages of the waterfall, right? When the requirements and the design phase is being done, the software testers don't sit idle. They don't sit idle, right? They are doing the test planning and they are designing the design also, right? They also have to plan the test, right? That these are tests we'll create and based on the requirements, these are different tests we'll have and you have to design them. Okay, you're not implementing them, but you have to do the parts, right? So those stages are done in the initial stages of the waterfall approach. Okay. However, in the iterative, right, in the agile models, testing is built into each iteration or sprint, right? What is a sprint? One iteration is called a sprint. Okay. So in each iteration, you do that, right? So you implement, you test, right? And based on the test, you have the review, and based on the review, you have the next requirements. And then again, the cycle goes on, right? That's the iteration. This means that testing happens continuously as new features are developed. Because code is delivered frequently, feedback loops are faster, and testing must keep up pace with the development. So first iteration of the development is done, you do the testing, and based on the testing, you give the feedback, and the developers will change in the next iteration. Again, the next iteration has been done, you test that, and based on that feedback, you find what are the bugs, defects, right? You give it back to the team, and so the cycle keeps happening. Okay, so agile testing relies less on formal documentation and more on flexibility, communication, and experience-based techniques. Okay, so what are the key agile testing practices? To succeed in agile, testing must pair each development task with a task. So what you do is you pair one development task with a testing task, right? So that this is a development task, you pair it with the testing task, right? For example, let's say you have the chat functionality, right? You're building the software develop your what were we building in scenario 2? You're building the social media, right? Social media app, right? Sorry. So we are building the social media app, right? So in that you have the chat feature, right? This chat feature, users can chat with each other. Okay. So you pair that with a test task, right? So one test task will be for creating test cases for the chat feature, right? That's a test task. Okay. In that you create the test cases. You create the test cases, you implement them. That's a test task. Okay. For other development tasks, right? You'll have other test cases. You pair each of those. So one task for the development, right? That'll be, they'll have a corresponding task for the test. Okay. So begin test planning early, right? Testers participate in the requirement and design discussions, like I told you, to understand what needs to be tested and how that has to be done. Okay. Review the design and specifications proactively. This helps detect defects before they make it into the code. All right. Testing as a driver of development. So now you have some different approaches. One is a test-driven development approach. Okay. Now what this is, right? In this, you start the development process by creating the test cases first. Okay. So first, the developers begin writing small automated tests, right? So you first write small automated test cases and define the functional or behavior, right? Only then you write the minimum amount of code necessary to pass the test. So first you're writing the test. So for example, let's say I'm building the chat feature, right? Or let's say you're building the social networking site, right? And that I want users to be able to sign up to the website. Okay. So I will write a test case to see whether the user is correctly being able to sign up to the website or not, right? I'll write a test case for that. Okay. So first I'm writing the test case. Now I'll write to develop the code, right? So based on a test case, I know what is the test case, right? So let's say I know the test case will check for the username, right? It'll check for the first name, it'll check for the password, right? It'll check for multiple passwords, right? The two passwords are there or not, right? And the two passwords should be same because we're signing up, right? And there should be a profile picture, right? There should be a, let's say there should be an introduction, right? So all these things should be there, right? So that test case has already been written. So now I'm writing my code according to the test case because I want to pass the test case. So the test case is already there. Now, if I want to pass the test case, I will have to write those test cases. I'll have to write the code accordingly, right? I'll have to write a code which will have the username. It will have two passwords, right? It will check, right? The code has to check that whether both the passwords are same or not, because I know that's a test case, right? And if I don't write the code of checking whether the two passwords are same or not, then my test case will fail, right? So I know that test case is there. So I'll write the code accordingly, right? I'll write the code to check whether the user has entered the profile picture or not, right? Because I know the test case is there, right? So that is the test-driven development. You write the test first, you make it fast, right? Then you write the code, right? Then you make it pass, okay? And then you refactor, then you make changes, okay? So similarly, you have the acceptance test-driven development also known as ATDD, right? ATDD is just extension of TDD, that's the test-driven development, by involving testers, developers, and business stakeholders in defining acceptance tests before any development begins. So here you define the acceptance test and then you develop accordingly. Okay, these tests describe how the system should behave from the user's perspective and are based on acceptance criteria, right? So what is your acceptance criteria initially that was done in the planning and requirement stage, right? You had defined an acceptance criteria. Based on that, you create test cases, right? That is your acceptance test cases. And based on that, you develop the code, right? That is acceptance test driven development. Okay. Lastly, you have the behavior, right? Behavior driven development, BDD. It builds up on the TDD and ATDD, right? It builds up on the previous two approaches by using plain structured language to describe expected behavior. So here you're focused on the behaviors rather than technical tests, right? So these descriptions often follow the given pattern, given, when, then format, right? So given something in initial context, when an action is taken, then a specific outcome is expected, right? So given this, this action is taken, right? So let's say given the sign up page, right? When an action is taken, such as the user signs up, then a specific outcome, let's say the outcome should be signed up successfully, right? That outcome should be there. Okay, this behavior driven development. All right. So BDD scenarios are understandable by all stakeholders because now you are not doing it technically, right? There are no technical terms here, right? So you are doing it not technically, but it's more in readable, right? So behavior, right? Behavior driven language, okay, which is understandable by all stakeholders. This makes BDD a powerful tool for bridging communication between technical and non-technical team members. Okay, so together the TDD, ATDD, and BDD promote early testing, improved communication, and increased automation. So these are the all core agile principles. All right, makes sense, right? Makes sense. Any questions? Any questions? Clear? All clear so far? Give me a thumbs up, right? Or give me a party emoji, right? Give me a party emoji if everything is great. You're understanding so far. Great, right? I see a lot of party emojis, right? Seraphim is dancing, right? Great, awesome, awesome. I love that. Okay, okay. Susan gives a party one, right? That is Zina, Stephen, Fadia, Presmic, right? We say understand but need time to study, right? We absolutely right. That is correct, right? That is correct. See, these lessons, these lectures are not meant that you understand 100% right now. No, right? It's not like that. It's not designed like that. That is not the approach. You have to go back. You have to revise, right? You have to revise, and that's why we have the assessments, right? So after this lesson, you'll have your assessment number 1, right? That will check you. You don't understand some question, you go back, right? You go back to the lesson, you review that, right? You understand that again, and you have your amazing TA, right? Seraphim is there. You book meetings with them, right? Schedule meetings with them, discuss, right? And that's the correct approach. I see a lot of parties, right? I see a lot of parties. Awesome, right? Awesome. So let's move the party forward. Let's move the party forward to Scrum, right? So Scrum is entering the party now. And what is Scrum, right? What is Scrum? So Scrum is an agile framework, right? Now we are talking about frameworks. What is a framework? See, so far you understood the methodology, right? What was the method of software development? That's an agile method, right? It is fast, adaptable, and flexible, right? That's the agile method. Okay. What are frameworks? See, frameworks are the guide that I talked about, right? So there's a guide which will tell you that, okay, now you do this, now you do this, now you do this, right? So agile is the methodology. Inside that you have different frameworks, right? And there are 3 key frameworks. One of them is Scrum, one is XP, right, which is extreme programming, and the third one is Kanban. Okay, so we'll talk about these 3 frameworks. They're the most widely adopted. Each framework offers a unique approach, right? So all 3 are agile, right? All 3 are based on agile methodology, but they're frameworks, right? They're like guides, right? So each one of them will guide you in a certain manner. Okay, so and the tools are tailored to enhance the efficiency and adaptability of development teams. So while there are other agile frameworks available, Scrum, XP, and Kanban are the 3 most commonly utilized due to the proven effectiveness in managing delivering high quality software projects. All right. So here, right, in Scrum, what we do, so the Scrum iteration process. So Scrum is still an agile, right? It's still agile. So you have the iteration process. Okay. So what do you do in the Scrum iteration process, right? Because you'll obviously have iterations because it's agile, right? And ultimately it's an agile methodology. So you have the iterations. What do you do in your Scrum iteration process? Scrum is designed to organize the work of a single cross-functional team. The team will do the software product development this way. Iteration planning. So first you create a plan for one iteration. You select the next features or sub features to deliver, choose from the highest priority items, define and estimate the task, negotiate the scope of the delivered product. Okay. Then the iteration execution. Then you execute that iteration. You implement the items in the plan. You fill in the missing requirements. You design the code. You integrate. You build, and you test the modules needed in the plan. Okay. You deliver, right? You deliver the results of iteration and give a demo, right? This is the first iteration. You give a demo. Okay, then steps 1 to 3 will be executed many times. So this is the iteration, right? So you do step 1, you do step 2, you do step 3, and then you repeat. Okay, so based on the release plan, each cycle is of a fixed length time box, right? So I told you, like, we have a time box, right? That is known as sprint. Okay, so each always end each iteration on the schedule, right? Even if it's not complete. So this is important, right? So let's say if you have 2 days time, right? So, or let's say 1 week, right? So 1 week is a sprint and one iteration goes for 1 week. Then what you do is towards the end of it, you are seeing that most of it is done, right? Most of what you required was done, but something else is missing, right? And you can do that in 2 more days. So if just you got 2 more days, you could have completed what was required, right? So what was declared in the planning stage, you could have completed that in just 2 more days. Don't do that, right? Don't extend that. Okay, just do that and just deliver and run the next iteration and planning meeting, right? So just complete it at that stage and then go in the next iteration, because if you delay that, if you take that, let's say 2 days more, then it adds on to the delays, right? So that's not the approach that we take. What we do is whatever is pending, that goes to the next iteration. Okay, so you don't expand you don't change the time limit, right? That time limit of 7 days is 7 days, right? One iteration 7 days, so 7 days. Okay, if you want more time, right, it goes to the next iteration. All right, so the team, right, the team learns to make good short-term estimates. So over time, most of the iterations will deliver as expected. So you keep understanding what are the different times, right? How much can be done, and over time, it becomes, right, estimates all fall in place. Okay. So what are the roles, right? What are the elements in Scrum? So you have a product owner who owns the product, right? You have a Scrum master. You have the team members, right? And you have these 3 roles, right? So basically these 3 roles are decided in Scrum. 3 meetings are there, right? One is the planning, okay, where you release and sprint, right? Second is the daily Scrum, and then is the sprint review. Okay, so these 3 meetings are there. First is in the planning stage, right? When you're planning the objectives and the requirements. Then you have the daily Scrum, right? Where you have the meetings for checking out how it is done, and the sprint review, right? So that's done in the end once the sprint is over, towards the end of the iteration, right? You review it, right? What was done, what is not done, and then it moves to the next iteration. Okay, 3 lists are created, right? One is for the product backlog, one is for the spring backlog, and one is for the impediments list, right? So these 3 lists are maintained. That's your Scrum process. All right. And look at this diagram, right? You can look at this diagram to see the Scrum process more, but I think we'll stop here, right? We'll stop here, and extreme programming we'll take a break here, right? We'll take a break of 30 minutes, right? And we'll come back with the next okay, I was hoping 9 to win. All right, okay, welcome back everyone, and let me quickly share the screen again. Quickly give me a thumbs up, right? Which duck win, right? Jixing says, which one won, right? I don't know. It was slow for me, right? Like the last part, I did not see it correctly. Jomana, can you confirm who won? I was seeing 9 was in the lead, right? And suddenly the screen
Yeah,
I
just
honestly also missed it. Raya,
it
can you
was.
confirm?
Raya
Can
will
you hear
post it.
me? It was duck 8.
Duck
Yes, I'll
8.
post it. It was duck
Me,
8.
you guys, I won. Yay! I actually wanted duck 6. But yes, thank you, Ines, for choosing duck 6 so I can choose duck 8 now.
Awesome, congratulations. And again, I missed it by just 1, right? But yeah, that's okay. It's okay. Close. Getting close to it. All right. Okay, let's move on, right? Let's move to the Next, right, the next framework that we had, that is extreme programming, right? XP. Okay, so XP is the short, right? The short form for extreme programming. And this is the second framework, right? So we were discussing about frameworks, right? So you had the agile methodology. Inside that, your framework. So one was Scrum that you saw. The second framework is extreme programming. Okay, what are the characteristics of this extreme programming? So by the name that it suggests, right? Extreme. So it is an extreme set of how is it extreme? Because it's an extreme approach to iterative development, right? So the iterative development, it takes an extreme approach to it. What does that mean? That new versions are may be built several times per day. Okay, so in one day you can build the new version a lot of times, so that iterations that you saw are happening many times in a day, right? In a single day you can have multiple iterations. Okay, so that is the extreme approach. Increments are delivered to customers every 2 weeks. So in every 2 weeks, you deliver the increments to the customer. Yeah, so you see how fast it is happening. So it's taking an extreme approach. All tests must be run for every build, and the build is only accepted if tests run successfully. Okay, so that's the approach you take. So you have the user stories over here, and from this diagram, you can see the requirements are given, right? You have the planning stage, right? You have a planning stage, then you go to the iteration, and in iteration, you get new stories, right? Then again, you go the planning, again, you iterate, and again, the planning and iterate, and in the end, you go into the acceptance test, you find some bugs, you go back to the iteration, and you rework on you fix the bugs, right? You get the latest version, again, you check the acceptance test, and here you have the test scenarios coming in. Based on that, you go for the customer approval, and accordingly the customer says, right, whether it's okay or not. And while in the release planning stage, you have the estimates, right? You have something known as spike, right? You have something known as spike, and where you have architectural spike also. So we'll discuss about what is spike, right? So characteristics, right? What are the characteristics of this extreme programming, right? Iterative development, right? It is iterative because it's coming under agile methodology. So it embraces short development cycles called iterations, focusing on delivering small incremental pieces of functionality. Continuous integration, it integrates code frequently, ensuring that changes from all team members are merged into shared mainline several times in a day. So you can imagine, right? If something is happening several times in a day, you have multiple team members working on it. So you need a continuous integration. This is a continuous integration so that everyone is on the same page. It should not be that you are working on something on a different version and your team member is working on a different version of the same project, right? That'll have inconsistencies. Okay, you don't want that, right? So you want a continuous integration of everything, right? Of all the team members merged into a shared mainline several times in a day. Okay, test-driven development, right? So write the tests before writing the code. In this approach, we always write the test first, and based on the test, we derive our code, right? So we make our code based on the tests that have been created, ensuring that the code meets the intended requirements and remains maintainable over time. All right. So those were the characteristics of extreme programming, and now we have some spikes, right? What are spikes? Anyone any idea what are spikes? Oh, there's a wonderful trophy by Raya, right? To Jumana. Jumana, congratulations for that trophy. Valentina says, while testing, will we keep all this in our mind, or will we have to ask around for TDXP just to understand how theoretic practical this will be for a software analyst on daily tasks? Great question, right, Valentina? Great question, right? Very very valid question. And see, the thing is that you'll be coming across these terminologies so many times, right? So even in this program, throughout this program, we'll keep working on these terminologies. Okay, so right now, because these are new to you, these terms are new to you, so you're thinking that okay, will I remember this term, what this term is, right? What is XP? But these terms are very frequently used in software testing. Okay, and you'll understand them, right? So by the end of the program, it'll be like a very very normal term for you. Okay, so don't worry about it. You'll understand what these terms stand for, right? And once that sinks in, right? Once that sinks in and becomes a part of you, then it's not an issue. Okay, and in case, right, in case anytime you don't remember something, so you feel free to, you can always discuss with someone, or you can search over on the net, right? So it's a second nature. just like all the Amazon acronyms we are used to, right? Absolutely, right? Absolutely, Suzanne. Correct, right? Second nature, right? Absolutely. Exactly, right? So it becomes a part of you, right? And trust me, right? By the end of this program, you'll understand all these terms, right? These terms will be at the back of your hand, right? Don't worry about it, because the program is designed to test you in so many places, right? You'll have assessments, you'll have mini projects, right? You have a lot of discussions and revisions, a lot of things will be there. Okay, so don't worry. Okay, so we have something known as spikes, right? So spike is an innovation of extreme programming in agile software development. It's a small story or work that is for answering or gathering information rather than producing the increment in a product. Okay, what does that mean? That sometimes, for example, a story is too large or overly complex. So perhaps the implementation of a third-party tool or library is poorly understood, right? For example, what is a third party tool? See, when we are doing, let's say we have a website, and I want to integrate some payment gateways, right? And so the payment gateway, there are already companies that provide that services. Okay, so that is a third party tool for me. Why? Because I'm designing a different website, right? I'm designing a different website. Let's say I'm designing an e-commerce website. Okay, it's a online shopping portal. And in that, I want to work on the checkout process, right? Where people check out and they are able to make payments. Okay, so for that, I need a third party tool, right? So a third company which provides the payment services, right? So they provide the service that, okay, you can check out, right? Like they will have the features for adding credit cards or PayPal, right? All different facilities will be provided. So that's provided by a different company. That's a third party tool for me. So they will provide their own library, which I can integrate into my project. Right. So if that is not properly understood, right, the implementation is not done correctly. So the team can't estimate the story, right? Perhaps we are unsure if we'll be able to complete the story due to some potential blocker. If there's some potential blocker in the third party library, right? Maybe we've not understood it correctly, we've not configured it correctly to work, right? Or something, right? There's some issue. So in these cases, we might want to build a functional or technical experiment to figure it out, right? So we want to build a functional or some experiment, right? Some test cases to figure it out whether that's working correctly or not. Okay, so we might want to look into something for a day. Okay, we might want to look up alternatives. So for example, there's some issue with our product and it's not working correctly with the third party, right? So the payment gateway provider that we had chosen is not working correctly, right? And there are some issues, right? There are some issues. They have some, let's say, regulatory things, right? And they do not allow certain things. And for us, right, it's not working, right? It's just not working. So we want to change it. Okay, so we can do some googling, right? We can do some googling. We can see which are the other third-party providers which provide the same services, right? You can experiment with other libraries or packages, right? So maybe if you're working on libraries packages, you can choose a different alternative. These are called spikes, right? You're changing, right? You're trying to figure out a different alternative approach, and these are known as spikes in your iteration, right? In your building process, these are known as spikes. Okay, you can call them as a research spike or architectural spikes or refactoring spikes if you wish. Okay, so these are the spikes, like you're finding an alternative path for the same approach, right? Some approach is not working for you and you're finding alternatives for it, right? You have to experiment, right? You experiment. These are spikes. Okay, some of the other distinguishing characters of XP are adaptability to the change, incremental implementation of updates, right? So every updates is obviously incremental because not just using agile iterative process, but you're using extreme version of it, right? It's an extreme. So every day you're building several of those. Okay, so feedback from both the system and the business user or a customer, and respect and courage for all who are part of the project, right? So these are the characteristics, right? Important characteristics of extreme programming. Make sense, right? Make sense. Does it make sense? Valentina says, my concern was not for acronyms, but on theory practice, right? Yeah, Valentina, that is a valid question, right? Okay, in the overall theory and practice, right? So yeah, see, that is why you have these examinations in place, right? ISTQB, and there's a internationally recognized standards. Okay, so you pass them, then you prove that, okay, I know this theory, right? I know this theory or practice, and I'm at the stage of clearing this, right? So you have to practice, right? You have to practice, you have to revise. Okay, revise, practice the concepts, and you have to go back to it again, right? When you're learning something new, it does not stick 100% in the first time, right? You go through a lesson once, it does not stick through. You have to revise, right? You have to revise, you have to go through the concepts again. And especially when you're doing your ISTQB exam later on towards the end of the program, you practice, right? You practice, you have to revise. Okay, and there's a lot of revision. You go back, you practice, right? You miss out on something, and it happens, right? So it happens slowly, gradually, but yes, you have to, right? You have to put in the effort for that. All right. Okay. Moving forward, right? Moving forward, Kanban. Okay, Kanban is the uh, third framework that we had. Right now, Kanban is slightly different from the Scrum and XP, right? So Scrum and XP are mostly similar, but Kanban is slightly different, right? How is Kanban different? Kanban is a visual workflow management method designed to help teams optimize their processes. So it is more focused on visual workflow. So managing the process visually. Okay, so for example, you can look at this image, right? You look at this image and how you have these cards written all visually, right? All visually. This is task one, this is task two, this is task three, this is done, this is not done, all visually. Okay, the characteristics here are principles. You visualize, you limit the work in progress, you manage flow, you continuous improvement. Okay, components are what? Board, work items, work work limit in progress, right? Metrics, benefits are what? Visibility, flow, collaboration, adaptability. Don't worry about these. We look at a Kanban in actual process, right? We have a lab exercises based on Kanban. Okay, so we look at an actual Kanban in work. Okay, so tips are what, right? You start small, you collaborate, you monitor, and you adapt. Okay, examples in softwares, you use it in manufacturing, you use it in marketing, mostly anywhere you can use, and it's a very widely used tool, right? Very popular, very widely used. Conclusion, Kanban enhances efficiency through visualizing, right? So this is the key, you do it visually. Okay, limiting work in progress and continuous improvement. Okay, I'll show you. We go into the lab, right? We'll go into the lab. Let me see what the lab is. So we'll come to the lab, right? In lab, you'll see the example of Kanban in real life, right? You'll see we will create a Kanban story, and you'll see how it works, right? So don't worry about Kanban. We'll look at an example on that. Okay, a real world scenario of agile transformation at Spotify, right? So let's look at an real world scenario of agile transformation, right? So Spotify, one of the world's leading music streaming platforms, you must have heard of Spotify, underwent a significant agile transformation to enhance its software development practices. So what they did, right? What they did. So Spotify came up with a new approach, right? They did something differently, right? Although they were going for agile approach, they did something differently. Okay, what did they do? So they adopted a unique agile framework known as squad model. So what did they do? They created a squad model. What is that? Which emphasized autonomy, cross-functional collaboration, and continuous delivery. They organize the development teams into small autonomous squads, right? So this is the key here. What they did was the entire development team was divided into small autonomous, right? Autonomous. So each team is autonomous, and those teams are known as squad. Okay, and each of those is responsible for a specific feature or component of the platform. For example, let's say in the Spotify, right? In case of Spotify, you have, let's say, searching of the music, right? You have to the search functionality for music, okay, and creating playlist, right? So that could be for a different squad, right? So one squad is targeting only that particular component, okay, and they'll make only, so they are responsible only for that feature, right? And other squad could be focused on other one, right? So they are autonomous. They are autonomous, right? Each one is doing their own, and they are responsible for their own work. Okay, so squads consist of engineers, designers, product owners, fostering close collaboration and shared accountability. Additionally, Spotify embraced agile practices such as Scrum and Kanban. They use Scrum and Kanban, enabling teams to iterate rapidly and respond to user feedback effectively. What was the outcome of this? The agile transformation at Spotify facilitated faster delivery of new features and improvements to the platform. By empowering autonomous squads and promoting a culture of experimentation and innovation, Spotify maintained its competitive edge in highly dynamic music streaming industry. The agile approach also enhanced employee engagement and satisfaction, as teams had more ownership over their work, where they were able to see direct impact of their contributions, because that is where the team is directly able to see that, okay, this feature is built by me, right? This built by us, okay? And they can see the feature, right? And they are directly responsible. Anything happens or any defects on that feature, they are directly responsible, okay? So there's more satisfaction, there's more employee engagement, right? More encouragement, okay? So this is how the Spotify took a different approach. It was mostly your Kanban and Scrum approach used, but they divide into squads, right? Different squads. Each autonomous squad was responsible for their own feature. All right, so let's look at a quick comparison of the agile frameworks, right? Of the different frameworks. So first we had Scrum. Okay, Scrum is what? Scrum is iterative and incremental framework for managing product development. It emphasizes teamwork, accountability, and iterative progress through sprints. Right, so you have some sprints, right? Sprints are what? The each iterative time period of each iteration. Okay. XP is what? XP is agile methodology focused on improving software quality and responsiveness to changing customer requirements. It emphasizes communication, feedback, and continuous improvement. Kanban, on the other hand, is what? It's a lean method for managing and improving work across human systems. It visualizes workflow, limits work in progress, and fosters continuous incremental improvements. Okay, we'll see, right? We'll see Kanban in practical exercise. But for now, right? So these are the key features, right? I want to show you this feature comparison, right? So yeah, look at Scrum, right? So this is the feature and this is Scrum. Tick mark means it's there in Scrum, and tick mark and XP means it's there in this, right? And this is the comparison. Now you see, right? Scrum and XP are mostly similar, right? Iterative development is there in Scrum, it's in XP. Incremental delivery is there in Scrum, it's there in XP, right? Continuous feedback there in Scrum, there in XP, right? Self-organizing team there in both of them. Okay, fixed length iterations, right? Sprints. So sprints is what I told you, very important keyword here. Sprints is what the fixed length of the iterations. Let's say 1 week is for the one iteration, right? That's 5 days for the iteration, right? So that's in Scrum, right? In Scrum we had those iterations, then the next iterations. It's not there in XP. Why? Because you have multiple iterations the same day, right? So there's no length, right? In one day, it's an extreme part of your iterations. Okay, so every day you have multiple iterations, so there's no fixed length of it, right? Emphasis on testing is much more here, right? Why? Because every day, right? Every day you're doing that, right? So every day you do that. Face-to-face communication, both of them have it, right? Continuous improvement, both of them. Okay, now work visualization, right? I want you to look at this, right? A Kanban board. Okay, work and visualization is not there in these two, because you're not visualizing anything. You're not seeing how things are working in the process, right? To what is being done, what is now to be done, or what is pending, right? You don't see anything visually. Okay, limit work in progress, you're not doing that, right? In these two, that's all done in Kanban. So we'll see that how that is done. We'll look at a Kanban board. Okay, flexible scheduling, all this is done in Kanban. So this is the advantage of Kanban. Okay, continuous feedback is in Kanban. Okay, that's why you saw how Spotify was taking Scrum and Kanban, right? They use a combination of these two. That's what generally the companies use. A combination of Kanban and XP, or Kanban and Scrum. Kanban will generally be there, right? Either you use Scrum or XP is the approach of that. Makes sense, right? Makes sense. Any questions so far? Any questions before moving to the lab exercise? Seraphim has shared a wonderful Kanban board, right? Great, awesome. Thank you, Seraphim, for that. Thank you so much. So that's a Kanban board, right? We'll look at it in the lab exercise also right now, but that's a Kanban board. Okay. Valentina says Scrum wins it all, right? Yeah, awesome, right? Yeah. Scrum very famous, right? Very popular, right? Very popular. You will often find teams using Scrum, right? So yes, absolutely. Okay. Clear, right? Is that clear so far? Especially for XP and Scrum, right? Scrum and XP, because Kanban I'm going to talk more about in the lab exercise. Okay, but Scrum and XP, right? Scrum and XP mostly clear. Any doubts? Any questions? Give me a thumbs up, right? Give me a thumbs up if it's if there's any question, or give me a thumbs up if it's clear. Theodora says maybe it's easier to understand in practice. Right now it's foggy for me, right? Yes, absolutely, Theodora, that is correct, right? That's correct, and that's why we have a lab exercise focusing on Kanban, because that can be done. And for Scrum and XP, you have to see it in practice, right? That's where experience counts, right? When you actually start working, that's where experience counts. Okay. So Stephen gives a thumbs up, right? BB gives a thumbs up, right? Okay. Others. Omari gives a thumbs up, right? Great, awesome. Jixing gives a thumbs up, great, perfect. All right, awesome, right, awesome. Okay, so let's move to the lab exercise now, right? So we have a lab exercise on Trello. Here we create a live Kanban, right? We'll create a Kanban board. Uh, for that, right? For that, what I want you to do is have Trello, right? So Trello is a website. You can follow along, right? You can follow along with me. Okay, I'm sharing the Trello link here with you. Okay, so just create an account, right? Create an account. How you create an account on Trello? Uh, if I can quickly show you, let me share again, right? 1 second. Let me share a different screen and show you how you can create an account in Trello. Okay. So see, when you open Trello, right? So I hope you can see this different website. So when you open Trello, you will have a website like this. Okay. And in this, what you have, you can either type in an email, or I would recommend what you do is you just click on this. Sign up, it's free. Don't enter any email. Just click on sign up, it's free. And after that, you click on continue with Google. Okay. You can click on continue with Google, and you can choose your email ID, Google account, and you can continue. If you don't have a Google account, then you can choose any other one, or you can sign up with your email address. All right. So quickly do that, right? Quickly do that. Once you do that, you will have a page, right? You'll have a page that will show you the dashboard. So quickly sign up on it, right? Sign up on it if you want to follow along with me. And if not, right, you can look at it, right? You can look what we are doing right now. If you're not able to sign up, Valentina says, is there any issue if I already have an account? Should I create a new one? No, Valentina, no. If you have the account, right, great, right? You can continue, right? You can continue. If you have the account, you'll see something like this, right? You'll see something like this. This is the workspace, right? So once you log in, you'll see this, right? You'll see this account like this, right? That'll be the workspace, okay? So I quickly want you to sign up, right? Sign up if you want to follow along, right? If you want to follow along, quickly sign up on it. And if not, you can watch it as well. I'll show you the exercise being done, and you can watch it and you can follow it along later on at your own pace in after the lecture as well. Okay, but give me a thumbs up, right? If you have signed up, it'll be great if you follow along. Awesome, right? Jomana says I can questionnaire asking me what I'm doing here, but I'll skip it to follow up with Harshit, right? Awesome. Okay. Theodora says thumbs up, right? So a lot of thumbs up, right? Awesome. Okay. Great, right? I see a lot of y'all have signed up. Great, awesome. Okay, I'll just wait for 10 seconds more. He says, I have signed up the account, but the wall is not showing the same as yours. Maybe what does it show you? What does it show you? Can you share your screenshot or something? What does it show you? Can you share your screenshot, BB? And Seraphim can help you with that, right? Seraphim can help you with the how you can get to the workspace. Okay, so this is the workspace that you need to get here, right? So once you sign up to Trello, this is the workspace you will find up. Okay, now here we can create a new board, right? So here you see create new board. In your free trial, you'll have some free trial versions. Okay, and like for me, it's 5 remaining. So click on create new board. Okay, you click on create new board, and it'll give you an option here, right? So board title. Okay, so if you look at our lab exercise, it says that we want to create a music streaming app, right? So we are developing a music streaming app. So just like Spotify, okay? And your task is to add a playlist feature. So our task as our team is asked to add a playlist feature, right? So we are creating the playlist feature. Okay, so we are creating a Kanban board to track how the progress is working. This feature will allow users to create, edit, and manage their own playlist. You need to track the progress of each step of the development using a Trello Kanban board. All right. So first thing we sign up, right? We signed up to the Trello website. Okay. Now create a new Trello board, right? So create a new Trello board, and the name of the board will be Music App Playlist Feature Development. The name of our Trello board is Music App Playlist Feature Development. So you type in your title here. It can be any title. You can choose a background if you want, right? You can choose a background from this if you want, and you can click on create. Okay, simply click on create, right? And that should create a Kanban board for you. Okay. Okay, I see some screenshots, right? Awesome, right? Valentina has given a screenshot. Awesome. Okay. BB says, I don't know what is this. I said, I see Seraphim is working with you. Okay. Seraphim, please see how BB is able to get to that, right? Awesome. Okay. So we have this, right? So we have this. This is the Kanban board, right? This is the Kanban board. Now I'll quickly tell you about the software, right? So Trello is the website, right? Trello is the website which provides you creating Kanban boards. Okay. Now, what exactly is a Kanban board? In this board, what we do, we have something known as list. Okay. So these lists are known as columns. So this will be, let's say, list one, right? This is list one. Okay. Now you can keep adding list, right? You add list, right? Here will be list two. Okay, this is list two. Now you again add a list, right? List three. Okay, like this, these are lists. And your task, right? What tasks you are going to add will be added inside this as a column. So this is column one. This is column two. This is column three. So inside this, you keep adding. So here I'll add a card known as some details, right? So you'll have details here, details one. Then you'll add again a card, right? Details two here. Okay, and you keep adding cards. So like this, you create something known as list, and in that you keep adding details. So for example, right, for example, let's see the list that we need to create, right? So those are our columns, right? So we need to create some basic columns such as backlog. So the first column that we are going to create is a backlog. Okay. So here what we create is, you can double click on it to edit, right? You can always double click on it to edit. Okay. You click on backlog, right? So backlog is what the first column is. Okay. Second column is what? Second column that we are creating is a to-do, right? So that these are our to-do tasks. Okay. So the second list is a to-do, right? So this is our backlog. This is our to-do, right? What we need to do. Okay. Third one is, you click on this, add another list, right? Third one is for in progress, right? What are the tasks that we have in progress? Okay, so you copy that, you type it over here, right? In progress. Okay, similarly, add one more list, right? Another list will be for your testing, right? That these are the things that we are testing. Okay, you can add one more, right? And if you're facing some issues in scrolling, right, left, right, you see that you have some inbox over here, right? This is an inbox. This is for messages, right? These are messages. And to consolidate with the team members, okay, this is only visible to you. If you want to remove this, you have this tool over here, right? In the bottom, you have this tool. You click on this, right? You click on this inbox and it'll go, right? So that part has gone. You click on it, it comes back again, right? You click on it, that part is gone, right? Only the board is active. So if you just want to see the board, this is for the board. If you want the planner, you click on this. If you want to switch boards, you click on this, right? So if I just want to look at the board, right, I click on my only board is only visible. Now I can add another list, right? It's much better to view. Okay, I'll add another list which is for testing, right? So I want to add another list for testing. Okay, added this, right? And the last list is for done, right? What tasks have we completed? So this is the last list. Okay, so quickly add all these, right? Add all these 1, 2, 3, 4, 5 lists, right? I want you to add 5 lists in your Kanban board, right? Quickly add that and give me a thumbs up if you are following along or if you're facing any issues so far in creating the board and creating these lists. Create these 5 lists, and Valentina gives a thumbs up, right? Great. Valentina is Teodora gives a thumbs up, right? Great. Awesome. Awesome, right? Ines gives a thumbs up. Jackson gives a thumbs up, right? Great. Perfect, right? Perfect. Okay. Stephen says, why you can't delete list, right? Great question, right, Stephen? Great question, right? So yeah, what happens is you cannot actually delete it, right? Yeah, awesome, right, Stephen? Excellent, wonderful. Okay, I wanted to talk about that, right? So here you cannot actually delete it, right? So how you delete it? See, for example, let's say I want to delete this one. Okay, done. Okay, done list, right? Let's say I've made some issues, some mistakes, anything. I want to delete this. So what you do is you click on list action. Okay, if you click on list action, here are some actions that you can do with the list, right? You have some list of actions. You can add cards on it. We'll work on cards, right? What are cards? We'll work on this. You can copy the list. You can move the list. You can watch it. And at the bottom, right? At the bottom, you'll see there's something known as archive this list, right? If you archive this list, then that list is gone. You see that done list is gone from here. Okay, so it is there in archives. Okay, archives means what? It's not immediately permanently deleted because you might want to bring it back. right? So it is archived. It is put separately, right? So it's like a temporary deletion. If you want to permanently delete it, then you need to go into options over here, something here in the menu, and you need to see the archived items, right? Yeah, here you see the archived items. Here you can see that you need to switch to list, because you can archive cards also and you can archive list also. You switch to list, you'll see this is your list over here, right? You can either restore or you can delete it. From here, if you delete, then it's gone, right? Then it's gone permanently. Okay. And now it's gone, right? And same thing for cards, right? We'll work on cards right now. Same thing is for cards also. Okay. So that is how you can permanently remove a list, right? Now click on this, right? And we had the list all done. Let's add that list. So these are the 5 lists that we have. Okay. Okay, clear, right? Whose question was that? Stephen, right? Okay, thank you, right? Awesome, right? Perfect. Okay, moving forward, right? Now you can add the project task. So in each of those, you'll add the project task. So for example, in the backlog, right? In the backlog, in our list backlog, we'll add the following tasks that we need to do. So backlog means these are the things that we wanted to do, right? It's coming from previous iteration. These are things that we need to do, right? So this is the backlog, right? So now here you add cards, right? So these are the cards. So these are the cards, right? So I click on this, okay, and see, you click on add card, right? And you can type it over here, right? Add this, okay, and you can edit this also, right? You can double click it to edit, and I don't know why. So you can add it over here also, right? So you can add description. So let's say this is my description. You can change, let's say bold, right? I want to change the style, right? I want to make it like a heading, okay? And you can add links, you can italize it, you can do your formatting, right? General normal formatting that you want to do, okay, and you can save it, right? You can save it. Okay, so this is our first one, right? So this is our first one. See, that's inside this, right? This
You
is
need to
the,
update the details one. Exactly.
yeah,
No, yes, exactly.
yeah. Right. So this one, right? This one, and this is the description actually, right? So this is your title, right? This is the title of your card, and this is a description, right? So inside this, you can have your descriptions, okay? All your descriptions is in details, okay? Like for example, let's say we need to design the playlist feature. The playlist feature, let's say the playlist feature should have, let's say, a green background, okay, with menu items in red. Okay, so you can describe it in details, right? And you save it, so you can do all the details, right? Like, so this is your card, right? This is a card. So what each thing is a card. Okay, now you can have multiple cards. So what you see is we have this cards, develop, create, playlist feature. So you copy this and you edit this one, right? Edit details too, right? So this is the second card, okay? And again, you save it. Then you have the third one, right? Let's untick this, right? Tick mark means it's done. Third one, right? You write, let's say, add songs to playlist. Okay. So like this, you can have multiple cards. So these are known as cards. Okay. And inside the cards, you can have the descriptions. Okay. So these are your cards. You can add all the cards. I'm just adding 3. So you can work on this, right? Edit playlist and save playlist to user account, test playlist, right? All these will be different cards. Okay. So you can add all these 7 cards. All right. 8 cards. Okay. Then what you do is now you move the task across the board. So once you have added all these tasks, cards, then you can move them across the board. For example, let's say we are working currently on developing create playlist feature. So what we can do is we can shift this, right? You can drag this and you can add it to the to do part. Okay, let's say for example, the design playlist feature, right? You can drag it and you can add it over here. So what are we doing, right? To do is over here, right? We are designing the playlist interface and we are developing the create playlist feature. That is what we are doing right now. Okay, and what is in progress, right? So one of them is in progress. For example, let's say the design part is in progress, right? So now you can see, you can visually see what is happening, right? What is happening, and let's say this part is done, right? In to do, you can click on this. Okay, so you can visually see what is happening, and like this you can move this in different boards, right? Not in different boards, in different list. Okay, so from this list to this list. Okay, so move the task in progress when you're actively working on them. After completing a task, move it to testing, right? So let's say this is done, right? Let's say this part is done, design playlist interface is done. Then you move it from here to the testing phase. Okay, and once the testing on this is done, then you move it from here to done, right? So that people can see, right? Everyone on the team can see what is happening when. Okay, I heard something. All right. Okay. So this is how you can keep adding features, right? Does it make sense? Does it make sense? Did you all add the cards? Were you all able to add the cards in your list? Valentina says, do we fulfill description as well? No, not necessary, Valentina, not necessary. I was just showing an example, right? Just showing an example. That's not necessary. So the lab exercise asks you to create these lists, add these cards, okay, add these cards, and then just drag them across the list. Okay, that's the lab exercise, right? They want you to they want to teach you how to create these lists, how to drag between them, and what this Kanban board is. So this exactly is your Kanban board, right? You can have multiple cards in different boards, right? So let's you can add more cards, right? Let's say edit playlist, right? We want to have an edit playlist feature, right? In the next iteration, let's say that comes in. So this comes in over here, okay? And then as the iteration moves forward in the next day you move this to, let's say, to do, and let's say this is in progress, right? So you can visually see what is happening, right? In the entire team, the entire team can see what is happening in the product right now, right? So in progress is edit playlist, okay? And what is being tested, these things are being tested, right? What is done, this is done, right? What is the backlogs we have? So you see, this is the visual appearance of the entire process, what is happening, right? That's why Kanban is very famous, right? And you can add details to the card, right? This is optional, but you can, right? For your practice, I showed you how you can add details. So this is for your practice, okay? So now I want you to go back to this lab exercise, do at your own pace, right? When you find time later on after the lesson, and just play around, right? Play around with it, okay? That's the point of this lab exercise. All right. Stephen has given a wonderful board, right? Awesome, right? Excellent, Stephen, right? That's wonderful. Okay, so that's a well-made Kanban board, right? Valentina says, I don't see any other member than me, so I assign it to myself. Yeah, absolutely, Valentina. Right now, you don't have any other members, right? Yeah, but you can share, right? So it's like your Google Docs that you have, right? You can share, you can invite team members, and so everyone can collaborate. Okay, so that's the beauty of Kanban, right? That's the beauty of Kanban, that it's a board, and you can collaborate with team members, and everyone is on the same page. Okay, so now if you move back to this, right? If you move back to the previous one here, right now you can see, right, why Kanban is so important, because it has a continuous feedback. Everyone is in the collaborating in the same this, right? You have the visualization, right? You have the work visualization, and you limit work in progress, right? You're limiting the work in progress, right? What is currently in progress, you see that, and you're limiting all that. Okay, so that is the key features of Kanban. And you see how it's different from Scrum and XP, right? That's the advantage of Kanban, and that is the reason why Kanban is definitely used. Additionally, you use Scrum, okay, because of this visual advantage. All right. Okay, some examples, benefits, and challenges, right? Okay, so overview, right? So some examples, benefits, and challenges of hybrid technologies, right? So hybrid methodologies in project management represent a blend of different approaches, combining the strengths of various frameworks to suit unique project requirements. They offer flexibility and customization, allowing teams to adapt the processes to specific project needs. Okay, examples of hybrid methodologies, you can use a Scrum plus Waterfall, right? So Scrum and Waterfall, you're using both of them. That's approach you can use. Okay, so integrating Scrum's iterative process in Waterfall structured planning and documentation process, right? You can do that. Okay, Kanban plus Lean, right? Combining Kanban's visual workflow management with Lean principles for continuous improvement and waste reduction. Okay, so you can have scaled Agile framework, right? A comprehensive hybrid framework that integrates Agile principles with Lean thinking systems and DevOps practices. Okay, you have Prince to Agile, right? Blending Prince 2's projects management principles with Agile practices to provide a flexible and scalable approach to project management. Okay, so these are hybrid, right? Hybrid. You can take two of those and you can combine them, right? So these are the characteristics, and So look at the characteristics, right? So it's flexible, right? Flexibility, you have integration, right? When you want integration, you combine agile, waterfall, lean, etc. for efficiency. Okay, scalability adapts to varying project sizes and complexities. Okay, adaptability is evolves over time with feedback and lessons learned. So conclusion is what? In conclusion, hybrid methodologies offer a versatile and adaptive approach to project management, right? It's adaptive and it's versatile, enabling teams to leverage the strengths of multiple frameworks. So you are combining multiple frameworks, so you can take the strengths of all of those. And by embracing hybrid methodologies, organizations can effectively navigate the complexities of modern project environments and drive innovation and growth. Okay, so best testing practices, generic skills required for testers, right? To succeed, testers should have testing knowledge, definitely. Okay, you should have attention to detail. So you understand why attention to detail is important, because it's hard to spot the defects, right? So spotting defects is hard. So attention to details is very important. And communication skills, like I told you from the very beginning, very, very important for software testers. Analytical and creative thinking, again, you have to have that analytical thinking to understand what is causing the issues, right? Why, or creative, right? What can cause the issues? Technical skills, definitely you need to understand how to use the tools technically and work efficiently. Domain knowledge is a plus point, right? If you have the domain knowledge for that specific domain of the project that you're working on, that's a plus point, right? Whole team approach that we discussed last time, everyone contributes to the quality. Tasks aren't siloed, right? Team members help whatever they can. Independence in testing. So what is independence in testing? Having independent testers increases defect detection by offering fresh perspectives, right? When you don't have independence, developers are testing their own code, right? That is no independence. Some independence means what? Peer reviews the same within the same team. High independence means what? Separate test team within the same organization. And very high independence means what? External testers from another company are coming to test, right? What are the pros of independent testers? Are unbiased and can challenge assumptions. Cons are that they may feel isolated or even seen as bottlenecks if not well integrated. Okay, so that's independent, right? Independent is when someone who's not involved with the code directly is coming from outside, outside for the team, right? Outside from the team. If it's outside of the organization, then it's very high independence. Okay, and when the developers, right, the same developers are testing the code, that is no independence. All right. Okay, makes sense, right? Let's quickly go through a knowledge check, right? So we have a knowledge check. Let's see how much of it you've understood or you've not understood, right? Let's look at that. Question number one, right? Which agile framework emphasizes the use of short time boxed iterations called sprints? So in which of the frameworks do you find the keyword sprints and the short time boxed iterations, right? Is it Scrum, extreme programming, Kanban, or feature driven development? Which one of these? Pawan says Scrum, right? Swarupa says one, right? Scrum, right? Scrum. Everyone is saying Scrum, right? Awesome, right? Of course, right? That is perfect, right? Great. Scrum, right? Like I've been telling you, Scrum in the iterations, the small iterations of Scrum are known as sprints. So absolutely correct. Okay. Question number two, which agile framework promotes practices such as pair programming, test-driven development, and continuous integration? Which framework supports these practices? Scrum, XP, Kanban, Crystal. XP, right? Susan says XP. Omri says 3, right? XP. Everyone says XP, right? Zero says XP, right? Perfect, right? Absolutely. That is absolutely correct, right? XP is 100% correct. Question 3, which agile framework visualizes work items on a board and limits work in progress to optimize the flow? Is it Scrum? Is it extreme programming, Kanban, or Crystal? Which one? Which one? Quickly tell me, right? Pawan says Kanban, right? Kanban, right? Stephen says Kanban. Absolutely, right? Absolutely correct, right? Kanban is correct. Swarupa says Kanban. Max is typing. All right, Kanban is correct, right? We just saw that, right? We just saw that, right? So Kanban is absolutely correct. We just saw the Kanban board. It is the visualization, right? Wherever we have visualization, that's Kanban. Okay. Question 4, right? Look at question 4. A financial services company is developing a new customer relation management system, a CRM system, to ensure thorough documentation and compliance with industry regulations. They start with a detailed requirement analysis and system design. However, they also want to be flexible and responsive to feedback during the development process. They implement iterative development cycles, allowing for regular updates and improvements based on user feedback. Which two methodologies have been combined to create a hybrid model in this scenario? Which two models have been combined over here? Ina says Scrum plus Waterfall. Susan says Scrum plus Waterfall. Theodora says Scrum Waterfall, right? Pawan says Scrum plus Waterfall. Stephen says one, right? Absolutely, right? That is correct, right? Scrum plus Waterfall is absolutely correct, right? So you are having the planning of Waterfall and the flexibility of Scrum, right? Absolutely. 100% correct, right? That is 100% correct. Well done. Okay, so you have another scenario. A manufacturing company wanting to enhance its production process introduces a visual system to track the flow of work items through different stages of production, ensuring that tasks are clearly visible and bottlenecks are quickly identified. Additionally, they focus on continuous improvement and waste reduction by regularly reviewing processes and implementing changes to optimize efficiency. Which two methodologies have been combined to create a hybrid model in this case? Which two have been used? Is it Scrum plus Waterfall, Kanban plus Lean, Scaled Agile Framework, or Prince 2 and Agile? Two, right? Kanban plus Lean, right? Kanban plus Lean. Everyone's saying two. Kanban plus Lean. Absolutely, right? Yeah, because you're using the visual, right? You're using the visual part of it for the Kanban, and Lean is for your continuous improvement and iteration. So this should be correct, which is absolutely correct, right? Perfect, right? Awesome. Well done, right? Well done. Great. Okay. So let's move to the last part of today's exercise, right? And that's the Kahoot. Okay, before that, right, let me just quickly go through the conclusion also, right? We have a conclusion, right? Yeah. Okay, so the key takeaways, right? The key takeaways from this was the waterfall model, right? The waterfall model you understood was a linear sequential approach to development. Agile emphasizes on the flexibility and collaboration. Okay, it focuses on adapting changes and continuous improvement. Scrum, XP, and Kanban are the popular agile frameworks that we did. Scrum is the framework that divides the project into time-boxed iteration called sprints, typically lasting 2 to 4 weeks. It includes roles such as Scrum Master, Product Owner. XP, you saw emphasizing on practice such as test-driven development, pair programming, continuous integration. Kanban focuses on visualizing the workflow. All right. And then you had hybrid methodologies, which blend waterfall and agile elements. Uh, and hybrid methodologies aim to leverage and structured planning of waterfall with the flexibility of iterative nature of agile. Okay, there's some further reading, right? Further reading that you can go through these links, and you have the self check, right? If you can answer these questions, like for example, this one, you can type in 4 if you can easily identify on your own, and if not, you can type in the corresponding number here based on it. All right, so I will quickly now go into the Kahoot, right? Let's go into Kahoot, and let me share the sound also now, right? I'll share the screen with the sound, and let's start the Kahoot. Okay, quickly. Let me host it live, and okay, so there's a game pin, right? So join in with this game pin that is loading here, right? And the Kahoot link will be there in your live chat, right? The link to Kahoot will be there in live chat, and this is the game pin, right? Join in with this game pin. I want a lot of y'all to participate, right? Just participate, because this reinforces what you've learned, right? And it's a good fun competitor, right? It's fun to win this. Okay, so quickly, 10 seconds more, right? 10 seconds more. Join in. We have a lot of y'all have joined in already, right? Quickly, 10 seconds more. I'll just wait, and then I'll start this. I hope you can hear this also, right? The music. Okay, 5 seconds more, right? 5 seconds more quickly. Okay, awesome. Let me start, right? Let me start. Okay, 2 seconds more. Anyone else wants to join in? Join in. I'm starting. Okay, Katizina, right? Okay, Joanna is also joined, right? Great, awesome, right? Awesome. Okay, let's see. Okay, let's begin Kahoot. All right. So question number one, fast, right? You need to answer fast. and you need to be very quick, right? The faster you answer, more points you get. All right. Okay. First question: which characteristic best describes the iterative model in software development? Right. Iterative model is a sequential and linear process, follows a fixed plan with little room for changes, builds the project in small incremental parts, or involves rapid prototyping and experimentation. Which one of these do you think is the characteristic for iterative model in software development? Absolutely right. A lot of y'all have got correct, right? Builds the project in small incremental parts, right? That is absolutely correct, right? That is 100% correct. Great. I see a lot of y'all have done involves rapid prototyping and experimentation. No. See, that's not rapid prototyping and experimentation is not your iterative model, right? See, iterative model is you build small incremental parts, right? You build one, then you go into the next one, right? You build one, you go into the next one, right? And that's your iterations. Okay. Rapid prototyping is not that, right? Okay, Theodora is in the lead, right? Theodora is in the lead. Inas is close behind, right? Very close behind. Katarzyna is 809, right? Awesome. Okay, next question. Which statement best describes a key difference between Agile and Waterfall methodologies? A key difference between Agile and Waterfall. Agile allows for late changes, Waterfall does not. Agile has a linear structure, Waterfall is iterative. Waterfall is more flexible in requirements than Agile. Waterfall emphasizes continuous user feedback. Agile does not, right? Which one gives you the key difference between Agile and Waterfall, right? Awesome, right? A lot of y'all have got it correct. Agile allows for late changes. Waterfall does not, right? That is true. Okay. A lot of y'all, three people have Waterfall is more flexible in requirements than Agile. No, Waterfall is not at all flexible, right? Whoever's, all those you have done three, right? Waterfall is not that flexible, right? We discussed that. Okay. We discussed that. Okay. Theodora is still in lead, right? Ina still following behind, right? Great. Awesome. Okay, next question. Which of the following projects would likely benefit from a waterfall project? Okay, a medical device with strict regulatory requirements, an interactive educational website, a social media platform with rapid feature updates, or a game that evolves based on player feedback. Which of this do you think will benefit from a waterfall approach? Right, we have waterfall approach, sequential approach, not going back. Great, awesome. I see everyone has got it correct except one, right? A medical device with strict regulatory requirements. Awesome, right? Looks you guys have understood the key concept behind it. Theodora still in the lead. Katarzyna has caught up, right? Caught up. Ines has gone third, right? Awesome. Okay. What does independence in testing mean? Right? Independence in testing, we just did. What does it mean? Testers check code they wrote themselves. Testing is skipped to speed up delivery. Testing is done by someone not involved in writing the code. Testers work without using any tools. They're independent. They don't use any tools. Which one of this do you think is independence in testing? Awesome, right? A lot of y'all have got correct. Testing is done by someone not involved. That is independence. So someone has written the code. Now the tester is independent, right? It's coming from outside. That is independence. Okay, that is the meaning of independence. So great job. Theodora's still in lead, right? Great, awesome. Ines following behind, right? Great one. Great going. What is a common risk associated with the iterative model? Reduction in team motivation due to long planning cycles, guaranteed on-time delivery of all project phases, scope creep from added features in new iteration, lack of user feedback during development. Risk associated with the iterative model, right? You have an iterative model, you keep repeating it. What is a risk? Okay, a lot of your, it's 50-50 divide, right? Yeah, most of y'all have got it correct. Scope creep from added features, that is true, right? That is true, because when you go into the next iteration, you again change the scope, right? You again make the plan, right? And you have the risk of increasing the scope that we discussed about, right? So reduction in team motivation due to long planning cycles. No, that's not correct, right? That's not correct. Team motivation is not reduced from this, right? Okay, Theodora's still in lead, right? Great, going. Theodora's on fire, right? Awesome. Next question. Which development approach uses plain language and the given, when, then format to describe expected behavior? Okay, is it behavior-driven development, test-driven development, acceptance test-driven development, or the waterfall method, right? Given, when, then, right? The format is you don't use technical terms. You're using given this scenario, when we click on this, then this happens, right? So given, when, then format is Awesome, right? Most of y'all have got it correct. Behavior-driven development, right? Absolutely correct, right? That is 100% correct. Well done, folks. They're a fire, right? On fire. Awesome, right? Ines also falling behind, right? Ines, very, very close, Ines, right? Come on, Ines. In Scrum, what is the purpose of sprint review meeting, right? So the sprint review meeting, what is the purpose of that? To discuss team member performance, to demo the results of the iteration, to identify impediments, or to plan the next iteration, right? What do you do in the sprint review meeting? Which of these? Absolutely right, correct. To demo the results of the iteration. A lot of y'all have also taken to plan the next iteration, which is not correct, right? You don't plan the next iteration. You're a demo of the results of the iteration, right? The iteration that has been just over, right? You're reviewing that, right? You're reviewing that. So you need the review of that, right? Ines has cross taken, right? Ines has overtaken. Well done, Ines. Katarzyna is just falling behind, right? Which of the following is not one of the three roles in Scrum? Which is not the role in Scrum? Team member, product owner, Scrum master, or project manager? Team member, product owner, Scrum master, or project manager, right? Not a role in Scrum, right? Remember, it's not the role in Scrum. Awesome, right? Project manager, right? Correct. Project manager is not a role in Scrum, right? Other three are there, right? You have the product owner, you have the team member, you have the Scrum master, right? Absolutely correct, right? Awesome. Let's look at the scoreboard. Ines in lead, right? Ines in lead. Awesome. Great going, Ines. Second last question. Extreme programming emphasizes which of the following practices? Okay. Does it emphasize detailed upfront planning, minimal customer feedback, test-driven development, or long development cycles? Which of these is emphasized in extreme programming? Which one? Do you do minimal customer feedback, test-driven development, long development cycles, detailed upfront planning, right? Test-driven development, right? Test-driven development, absolutely, right? Absolutely. It's not detailed upfront planning, right? You don't do detailed upfront planning. You do a test-driven development. That is correct. Absolutely correct. Okay. Ines in lead, right? Ines still in lead. Katarzyna following behind, right? Come on, Katarzyna. Theodora, you can. Which of the following frameworks is known for its visual workflow using boards and cards, right? Waterfall, extreme programming, Kanban, or Scrum? For visual boards and cards, which one is known for it? Waterfall, extreme programming, Kanban, or Scrum, right? I want everyone to get this correct, right? No one should get this incorrect, okay? Awesome, right? I see all 16 correct, right? Kanban, absolutely correct.